There we go. Everything should be fixed now. Yep. Sorry about that. Yeah, I had some issues before and we fixed all those and then they didn't get saved. Sorry about that. We're back. Yeah. All right. So, should be able to hear the audio, right? Everything's good. Test, 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 test. Okay. Well, rip all the viewers. Sad day. I guess I'll have to pay for more viewers then. Damn it. Cargo run. We'll get this up and running. This will parse that log. And here's what we see. And we can do a release build to make it parse a little faster. I don't like slow parsing. There we go. Much better. And if we take a look at the mini dump that we generated, we put that at d calc dump. Got this mini dump in this state. And let's take a look. So the allocation of interest is at ODC0. And for some reason, that's not in the heap log. I'm gonna delete the trace files and type start log. Let me make sure that I'm using this correctly. Need to learn Windbag. Oh, Windbag is amazing. Windbag is the best debugger out there. Start heap PIDs 0 stack walk. Yep, that's correct. Stop heap session. And then that's going to do a parse log, which will do it with symbols from trace.etl. So we're just going to see what's going on here. I'm not quite sure why we're not seeing those transactions. Maybe it's because we have page heap on, but we kind of need page heap on. So that should be logging those transactions. We're going to run our crash. We're going to make a quick note of RCX ends in DC0, and then we're going to stop log. See what happens. Is that a suspiciously small number of heap operations? Yeah, it is. Latest Windbag heavily leaks memory during KD. Interesting. I haven't run into that yet. Or maybe I just don't notice or care. I don't know how bad the leak is, but I haven't had any issues. But almost everything I do is short-lived sessions at Windbag anyways, so I might not notice. Preview one. Oh, yeah. Oh, like Windbag X. Yeah, I don't use those. I just use KD. I'm actually not a fan. Even though I know it provides improvements and has like time travel debugging and a bunch of cool stuff, blah, 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 blah. At the end of the day, it's not necessarily my cup of tea. Okay, so that generated this trace. Let's take a look. Yeah, that's not right. Maybe it's page heap. Let me turn off page heap. See if we'll try and do it again. See what happens. So we'll do G flags. I went through to calc.exe minus HPA. We're gonna start log. Launch calc. That was totally not what we wanted to do. Cancel that. Del trace star. Start a log. That's running. Run this. Looks good. So that took a little bit longer to crash. Obviously that makes sense because we had page heap off. Now we're gonna do this. Unless there's something not being nice about this. HKLM Maybe these tracing flags aren't being used. The memory window is broken in X. I've never really used the windows. I'm not a huge fan. I just like typing everything with the command lines. 320 workers. That's some good stuff. Any new crashes? 2129. Did we look into this? We're gonna look at crash.regs. And then this will allow us, we'll just look if the faulting address is a stack address. It is, then we know it's a stack exhaustion. Okay. Really? Really? Oh shit. Oh shit. Yep. I can feel this. There's some memory pressure. Something's using all my RAM right now. TKO fuzz. Yeah. That's probably why OBS closed. Why would that be so high? I guess that has the whole input database in memory. How many inputs do we have in there? 2,658. I don't think those inputs are that big. Coverage. Are those coverage records large? For some reason, the server is using a lot of RAM. Stream's still working, right? The chat's doing some weird stuff in OBS, yeah. Okay. Memory allocation of 1 gig failed. That is 7.7 gigs of non-page pool. We can just shut down some VMs. We don't really need the IDA VM right now. Okay. Should be better. Yeah. Why is this using so much RAM? Have all the input databases. I guess maybe all the file operations. There must be something I'm caching that I don't need. We're fine. So this has all of the transactions now. I'm guessing it is a page heap thing. Let's take a look. Stack walk. So maybe this doesn't work with page heap enabled, which would be really strange. Stack walk. Oops. Stack walk. Heap alloc. I just want to enumerate all the different things. I actually might xperf help stack walk. All the heap stuff. Maybe I need virtual alloc and virtual free. Virtual alloc and virtual free would probably get us the information we need. I'm feeling the music right now. Jamming. Pool alloc session. Find stir I alloc. 2. What? Heap alloc, pool alloc. Yeah, I'm guessing maybe you just see them as virtual allocs. So I don't think it's the heap range stuff. Okay. Well, if we can use procmon in this case. With page heap, we can use procmon, I think. I'm just setting this up. Remove, blah, 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 blah. Procmon, I think, shows virtual Alex. No, it doesn't, does it? If the image path contains win32, I know it's not on screen, calc.exe, then include. Let's see, we'll turn page heap back on, G flags, I win32 calc.exe plus hoopa. Get this going, okay, saw the crash. Load image, yeah, I don't think we get that. I'm gonna stop logging. That's how to scroll, it's this. Okay. And then we want to do drop filtered events. Yeah, is there any way that you could turn that on? I don't know if there are events that we could add. Options. Profiling events, nope. Configure symbols, select columns. Yeah, I don't think so. VM map kind of does it, yeah. Yeah. Heap, PARCX. Allocate heap. RTL allocate heap. Yup. The fact that that doesn't work with page heap is really annoying. For someone who's fairly inexperienced with reverse engineering and exploit development, especially on Windows, what books would y'all recommend? I think a good, I don't know, like I haven't read too many books, but going based on what other people say, the Shell Coder's Handbook is really good. That's probably more for like exploit development. The IDA book is pretty good by Chris Eagle, pretty solid. I've read it myself. While that covers mainly how to use IDA, it also covers like good practices for reverse engineering. But honestly, the best way to learn is to just find something and hack on it. You know, we're fuzzing calc.exe, which is like, what is the point? But we're learning things, we're having fun. So it's awesome. I love it. So we've got those. What do I want to do? I'm trying to figure out if I want to attach a debugger and then kind of watch everything as it happens, or if I want to get heap logging working in some different way. I know some tools will do it, like API Monitor would do it. We can grab that. Do I have that installed? No. So we'll grab API Monitor. Hopefully this still works on latest Windows. It clearly hasn't been updated. I haven't seen Rotab around in a long time. Okay, so I can do API Monitor 64-bit. Okay, and menu bar, I didn't mean to do that. Drag, there we go. Okay, what I'm gonna look for is, I just want virtual alloc virtual alloc ex numa, virtual freeze. We don't really need the protects. And then we're gonna do this on, oh yeah. Oh, we got to this song again. Do do do. So let's see if there's a way that I can do this on an existing. So I need to. Like I can create a new calc, but I need to delete the reg keys. So I guess I'll just run that reg command manually. So we just need to do reg.exe delete this /r. /f. Okay. Now we can start a new calculator process under this. So we're gonna do create win32calc.exe // Windows System 32. Go. Okay, that's up and running. We should be able to see all the virtual allocs and stuff that happen. I don't know if we're going to see them live or not. Let's close this. What? Didn't we turn these on? API filter. Why am I not seeing the logs? What's going on here? Everything's fighting me today. Let's try a different one. Let's try this. I mean, maybe we just haven't done something that allocates yet? I doubt it. Man, tools do not like me today. That's really strange. I don't think we need admin. Unless there are different functions, system services. Well, we're just gonna turn it on for all the heap stuff and just see what happens. Okay, so this we got. All right. Okay, we have page heap on, right? Huh. Yup. We'll remove this. And now I'm just gonna do, I guess we can do just the heap stuff. We'll do heap alloc, heap free. We'll do heap realloc. And then we're gonna run our, we want to delete the stuff here, the reg key stuff. I deleted the reg keys. And then we're gonna slightly modify this application. Doesn't need assembly either. And this will no longer launch it. It will just attach to an existing. There we go. So now what we can do is we can create a new calculator here. And then we can run this. And we got a crash. Fantastic. Everything looks good. Heap PA RCX. Looks good. And then we should hopefully have those things logged, which oh, were they local allocs and freeze? Ah, is that what it is? Did they use local alloc and free? Global free, yep. Local. Okay, now we're gonna do it. We'll use the static import. Okay, now we've got stuff coming in. Run this. There's our crash. Heap PA RCX. Looks beautiful. Now we can look through here and return values. So now we can kind of start evaluating what these things look like. Yeah, it's local alloc. So we're gonna look specifically for RCX's value. So this, we're gonna do a find. I don't know why I couldn't copy that. Okay. need to find a good way to filter here. Display filter. Filter. Okay. What do we have? Hide API. Enable breakpoint. Select columns. Find. Like that address has to exist. 13A8. So we're looking for 13A88DE as a return. It's actually a lot of Alex and Freeze. A8DE. A8DE. I'm just assuming that they're in order. They probably are. A8. We tried to search for it. A8DE. I'm not seeing that. A8DE. Let's see if like this works. Okay, that does. A8DE. Oh, we were looking for RCX. We want to look for the heap allocation, this user adder. My bad. This will hopefully get us in the ballpark. Really? That's coming from RTLP allocate heap. Oh, we need to grab those too. Okay. Memory management. Global and kernel. Where are the RTLs? And the RTL, I think everything will end up going through the RTLs. So we can just look for those. Let's just search RTL allocate. Find where these are. Allocate handle. Okay. Allocate heap. Free heap. Reallocate heap. Okay, we're gonna try this one. Doop, doop. Okay. Heap PA RCX. Oops. PA RCX. This address should exist. Having some like delays here. I need to double check that I'm not ooming. No, we should be fine on memory. Okay, so I'm gonna delete the old log. Got the new log. Are you kidding me? I don't think there's an RTLP allocate heap hook here. There isn't. And I doubt they would have that. Because that's an internal one. Yep. All right. Guess we're debugging. Going old school. See? When everything fails you, you just gotta get into the meat of her. All right. Reset. We're gonna use WinBag. We're gonna open an executable. C:/Windows system32 win32 calc.exe. All right. Good. We've launched a calc. Now what we're gonna do is we're gonna put a breakpoint on this. All right. Let's see. Really? Where did we put a breakpoint? Layout standard mode? How do we not hit that? Oh, that happens early. That happens really early. Okay. How did I get into reverse engineering? Ooh, that's hard to say. I've always kind of had an interest. I don't know, hacking just sounded elite, and I wanted to be a hacker. So I just like made some game cheats and then got pretty comfortable with assembly and reverse engineering stuff. So, okay. So we're gonna look at, so we never hit that breakpoint, which means that this allocation happened really early, actually. What is the intended behavior? So then that makes me think it's a type confusion, because this allocation happened very early on in the application. Which makes things actually really difficult for us, because we're gonna really struggle to fill in fields. But yeah, this is very likely a type confusion at this point. Huh. The thing where an executable is loaded, and then there's an array with function pointers somewhere outside the actual code, such that when a function is called in your code, it does an indirect jump. Is that a thing with AMD 64? I'm not sure exactly what you're referring to. You're probably referring to like the GOT section. Well, GOT is what elves call it. So yeah, there is like if we were to look at DPS of Win32 calc imp under realloc. I need a better example. Imp. We can just do X star this. So all of these are going to be like function pointers for all like the imports. This is just kind of like standard import table stuff. If that's what you mean. So we have like the import table, and this has like a bunch of the pointers to all the imports that get filled in. Okay, yeah. Yep. Yeah, it's still a thing. That'll pretty much always be a thing. It's like required. Why do they do that? This is because the application itself needs a way to reliably call these things. So let's say this application wants to call a local free stub function. Now, this application has to be able to emit code that can invoke this function. However, this function is in a different module. It's in a different DLL, or, you know, if you want to think about it that way. So effectively, the application needs a local storage location to place the address for that. Don't tell me that. What? Yeah, it's basically the dynamic linking process. It's just standard imports. What games in particular? I can't remember what the first game. I wrote cheats for Tibia. I wrote a lot of cheats for Tibia. That was kind of a standard thing that I did. But yeah. So we might actually want to look at a couple different crashes, just because this one, I think we can do better. I think we can do better than this crash from what we have. So my concern with this is that it's going to be very difficult to get a groom early on in the it's going to be very hard to get a groom early on in the process. So if you look at this layout standard mode, I guess let's see when layout standard mode gets hit. So I'm gonna delete the registry keys. We're gonna put a breakpoint on this. So this gets hit very early on in launch before the window even shows up. So this is kind of laying out where everything is. It pops up. Let's see if I can get that to happen again. Okay, if we can cause it to happen again, we might be able to actually get a groom in that window, because we could cause a mode switch in there. So what I'm actually going to do is I'm going to go into a different mode, and I'm going to see if the repro still happens. And it does. So in this case, we got a crash at B0. I'm gonna try a different mode as well. We're just gonna we're gonna see how this crashes in a couple different modes. This one looks pretty bad. This is definitely just invalid data. In fact, this looks very type confusey. I'm guessing we're sending it a message to do something on a button or mode that is not currently active. And that's causing a type confusion, which is causing yeah, of course. So we're gonna see R8 is compared with that. So I'm just going through and I'm trying to see the different ways that this can crash, like the different states that this can crash in. What do we got? Get one a long pointer. Check in on our fuzzers. Archive is churning. Debfi, that's running too. Let's see how often this is printing. That looks pretty good. Yeah, we definitely got a perf increase by spinning that up. 320 workers. Now at 2.3, it's probably running at like 3 fuzz cases a second or so, maybe even longer. Been running for over 2 hours now. So let's go take a look at the crashes, what we have so far. Dev, TKO fuzz, Franzia. See if we have anything new. We have one from 5 minutes ago, which is a user write. We can see this might just be a stack. Yep. CR2 is a 6.3. Stack is currently there. Yep, that's a stack one again. This one. That's just a null deref. Don't really care about that. Okay, so this can crash seemingly in a couple different ways, depending on the state of the application, which really makes me believe that it's a type confusion. And if we look at where the allocation occurred, in this case, well, yeah, that doesn't even exist. That's getting it from racks. DPS racks, heap PA racks. This was allocated in layout scientific mode. So basically, we're operating. I think this is straight up type confusion. But in the case of type confusion, we're probably not going to get. We're probably not going to be able to get a. We're kind of at the whim of this address here. So if we take a look at this address, we're gonna deref at like some offset into this address. I don't know why my WinBag keeps freezing. Oops. So if you look at this address here, got a bunch of initialized fields. So I'm guessing this contains like the current operating mode. With the type confusion, I think we're really gonna struggle to groom in something there. So what we actually want to do is we want to find, is that all of our ODs? I want to get the crash where we were crashing on CO. Have we looked at 5.1? Basically, there might be a state that we can get the calculator in that would cause it to crash. Like, let's turn on some history and stuff, turn history off, turn on some of these conversions, and we're going to see if we can get a couple different crashes. NTDLL. Okay, this one's a straight up null deref, UB rip, DPS RDI plus B48, keep PA of this. Heap of RDI. I don't know why that's not in the heap. Oops. Win32 calc.exe. We could turn off page heap and see kind of these different states that it crashes in. But we're about to probably write a fuzzer for this, and I want to see how many different ways that this crashes. That's probably the direction we're gonna head. So null deref, restart without page heap. Still null deref, restart. Switch to a different mode. We'll go to programmer mode. This one crashes as a kind of a null deref. Restart. Switch to a statistics mode. Okay. Standard mode. This is a heap corruption. So if we're in standard mode, we end up in a heap corruption state. This probably does a double free. Analyze V. Well, I mean, we've officially confirmed that we can get heap corruption. So that's a thing. So we know heap corruption is possible. That's pretty fucking cool. Hell yeah. With heap corruption, a lot of things start coming into play. It might be hard to like get the heap in the right state every time, but we could probably find a way. Let's take a look through some of our other crashes that are interesting. See if anything new showed up. Nope. These write users, as long as they're not stack, it's probably fine. CR2 and RSP. Yep. It's stack 3A. This one is not stack. We can check this one out. This one might be interesting. PF this. It also depends on the mode that we're in. When 32 calc.exe. Well, here is a windbag crash, just in case you're interested in a windbag crash. Here's a windbag crash. So that's a thing. When you're in the fuzzing mode, everything just kind of hands itself to you, you know? Windows System 32, Windows calc.exe. Alright, we got page heap off. We're gonna run through this page fault, see what happens. Okay, it's this corruption. Seems like everything kind of stems from these type confusion things. Standard mode. Okay. Not quite what we want. We want better. We want better than that. Let's go into stats mode, see what happens. That one crashed as well. Kind of in a much different state. That one actually like ran for a while. Let's turn on history, programmer. Okay, we'll delete the red key. This is in the clean states. This will hopefully repro like what actually happened. Huh. We want page heap on again. Page heap is back on. Restart it. Page heap confirmed. Okay. We might want to turn on page heap in the fuzzer itself, such that we could try and figure out like what these different crashing states are. I think it's time that we start fuzzing the different ways things can crash. Apologize for throwing you off target, off topic. Please understand this is important. Have you looked into the 48's internals, the CPU assembly of the HP 48G? Nah, I never have. I've never really done much programming on the HP calculators. I've never really had a need for it. I prefer their input mechanisms to the 48's internals. Unless that's not what you mean.
I guess I'll never really know.
Okay. So, I think what I'm going to do is I'm going to make another tool using mesos. And what we're going to try to do is we're going to try... I think what we're going to do is we're going to grab all of the crashing inputs that we have. And then we just got a new crash. It's on null bref. I think we're going to take all of these crashing inputs and we're going to see how they crash natively with different page heap modes. Because we know that some of these will reproduce in interesting ways. In fact, I actually want to reproduce one of these in the states where it's dereffing 30, 30, 30. So let's see if we can get this to work on one of our Windows 7 VMs.
Have you ever felt that way?
Just in case it's a different Win32 calc, there's a chance that it's crashing in a slightly different way, or the IDs aren't lining up. So we just need to make sure we can reproduce this. So we're going to grab this crash. We're going to take our inject program. We're going to turn on the auto start calc stuff again. And we're going to run it. We're technically in debug mode. Cargo clean, cargo run. Okay, we'll go into here. Here's our binary. We'll copy this into our VM. Man, we actually can't do that. We gotta shut it down quick. We gotta mount the drive and go through all that rigmarole. I'll do that on another monitor. Blah blah blah. Where do I save it? VHDs. Win 7 fuzz calc. Just throw this into there. Then we also need the repro case. Let's grab all three of these. Paste those in. Good. Unmount the drive. Boot up the VM. Are my servers running Gen 2? Nope, just Debian. Gen 2's overkill. It's just unnecessary. I've run my fair share of Gen 2. I'll run Gen 2 on a workstation or something I interact with, but not on something that I deploy to. I'm not gonna deal with the instabilities. So I should be able to do inject ID sequence, OXOD, see what happens. That's not gonna work because we don't have Win32 calc. It's calc.exe. We gotta shut it down again to get that image in there. Okay. And VHDs, Windows 7. This. Paste that right in there. Eject. Boot it up. Alright. Now we're gonna do inject ID sequence, OXOD. Why is this not working? Calc.exe. Calc. Okay. Nice. Okay. We're just gonna get rid of the auto start stuff and we'll just manually handle starting it and setting the registry commands, I guess. Get rid of the spawn. Sorry. Good. Gotta open that file again. VHDs. This. Paste. Yes. Yes. object. Forgot to build it? I don't think so. Did I? Maybe. I wouldn't be surprised. Not a big deal. Okay. Inject OD. This is just gonna wait until I open calc. There we go. Okay. Okay. Nice. We'll open up a windbaggy. Whoops. Windbag. We'll launch a calculator under here. We'll just do this. And open executable or attach. Calc, yes, go. See what happens. So this one is crashing in the plus 2C8. Oh, we got page heap on. Okay, let's get page heap off. CMD admin, oops. What do you call it? Windbag? That's what everyone calls it. It takes less time to say. G flags I calc.exe minus HPA. And let's see. Let's see. Should be good. Should be able to open a calc, put it in standard mode, turn off the history. Gonna attach to the calculator. Null deref. Okay. Okay, we'll try and launch calc.exe in here. I just want to see if it crashes in the same way. This crashed in a different way. Let's try it again. Crash in a different way. I just want to see if it eventually crashes in the way that we want. Okay, we're gonna try a different one. To a oh, the NTDL. Okay. Let's see if we reset the modes. Everything looks reset. Huh. I mean, this is doing a null deref and then calling. So that's a thing. So like if somehow we got control of that, we would have code execution. So I'm gonna take a quick like 3 or 4 minute bio break. I'm gonna refill my scotch, and I've got some ideas for when we come back. So we're gonna get a string in that field. So see you guys in a bit. Sorry about the long 2 minutes there. How's it going? What have I missed? Did we pop calc while I was gone? No, not quite. So we got any new crashes? Nope. 2210. Last crash was 15 minutes ago. All right. I'm gonna switch up the music in a little bit. Basically, next time I can get a transition. But yeah. All right, we got this up and running. Everything's good. So effectively what we need to do now is we want to figure out the different ways that this can crash. So we could try and root cause this bug and go the hard way and try and figure it out that way. Or we could just fuzz these inputs through pretty heavily, and we could try to see if there's any way that we can cause them to crash in another state. So we know that we have some use after freeze. We know that we have some uninitialized memory accesses. And I think the use after freeze is only on closing. Oh, yep, I'm still on intermission. Sorry. Thank you. Okay. So, that's what I get for not being a professional streamer. I'm trying to think what the best way to go about this is. So, basically, I want to actually kind of stop some of this crash deduplication. So these crashes are kind of deduplicated based on their categories. And what I kind of want to do is I want to see the different ways that they can crash. And I also want to see different ways that I can cause allocations to occur inside of calc. Because if I can cause allocations to occur, I can then kind of intermix random allocations inside of the fuzzer and see if any of those allocations end up bubbling up to the surface and showing themselves in a crash. So what we can do is we can look at, we'll shut down this VM for now, save some RAM. Nice. Okay. All right, what do we got? So basically we need to figure out what could potentially cause a large allocation in calc. So the thing I'm thinking of for using as a grooming primitive is pasting things into the calculator app. So what I want to do is, we can actually do this the really quick and dirty way. It might not succeed. So first I'm going to make sure that page heap is enabled, which I have on one of these things. We're going to turn on page heap. We're going to open the calculator. I'm going to make a file. In this file, I'm going to put a lot of A's. Specifically, I'm going to use 625 A's. You might be thinking, wow, that sounds like a fancy number. Well, it just happened to be when I lifted my finger off the V when I was pasting. And we're going to attach to calculator. Looks good. And we're going to search through memory. You know what? As stupid as it sounds, cheat engine is actually the play here. I know that sounds stupid, but cheat engine still is the fastest way to search memory. It just is. Oh, cheat engine 7.0 came out on August 20th of this year. Wow. Cheat engine 7.0. Look at this. That is incredible. If I remember correctly, cheat engine had like some sketchy installer. Some like really sketchy S installer with like ads and stuff. Looks like an MSI installer now, which means they shouldn't have control over things like that. No, no, I don't want a vast antivirus. Get out of here. You almost got me. You almost got me, Avast. You need to trick people into installing your shit. Maybe your shit ain't too good. All right, we're going to attach to calc. We're going to search for a string. We're going to search for A. and UTF-16. Son of a bitch. How many A's are in here? Maybe we'll have to do B's. Browse this memory region. So that's not too many A's. That's a healthy amount of A's. It's not too many. It's not too little. What about this one? That's just a repetition of it. So we can just put more A's, and then that will make us pretty confident. So there is no place in calc that has A's, that many A's. So I'm going to do this and paste and see if we got A's, and we didn't. And I'm going to do this and paste some A's. That might not take letters. Uh-oh. Oh, there we go. We got some A's. And if we browse this memory region, I'm gonna hazard and say that those are our A's. So let me try and figure out which one caused those A's to get allocated. So we're gonna make a new calc. And basically I want to find where I can paste onto the screen and find A's. So we'll attach to the newest calculator for scan. I think Cheat Engine just crashed. Not quite. First scan. Okay. So if I paste into this dialog, I don't get A's. Okay. If I paste into unit conversion, first I'm going to double check there aren't A's. I'm going to paste into the unit conversion from box. Control V. Okay. Obviously nothing showed up, but if we look in memory, we have our A's. In fact, we have one allocation of A's. We're going to do a win bag. We're going to see where those A's get allocated. Here we go. And we're going to do heap PA 1D3 9B 3C FB 36. And here we see there's an allocation of 4 E6 bytes. If we look at what 4 E6 is, 4 E6 is 1254. That is oddly close to double this. But this is in what's up? NI0 N0. We also had Gamma Aredes followed. Thank you so much. Dwindling Chaos, I might have read that one off. And Tyranchos TV? Tyranchos TV? Man, it's so difficult. I think it's Unicode, so that makes sense. It absolutely does make sense. Thank you for reminding me that this is indeed Unicode. So if we take 1254 divided by 2, we get 627, which means for some reason it allocated room for like 2 extra null bytes, but whatever. It put like a null 4 byte. Thank you for that reminder. I would have not noticed. Okay, so we have now learned that we can cause kind of arbitrary heap allocations to occur, and is that one even leaked? This isn't an active allocation, so let's see what happens. I'm gonna make some B's, %SABG, and I'm gonna paste some B's in here. We're gonna break, and we're gonna see if this allocation is still active. It shouldn't be. I'm guessing this gets freed. Yes, so this one did end up getting freed, but it stayed active while the paste occurred. So what we should be able to do is do, we want to the edit box, we want to send A's. So I need to figure out which location that is, and then we're gonna try and programmatically send A's to that box. So in this case, we're gonna look at, we could actually see what message that is. Handle when main message. I'm guessing there's probably like a right-click paste. I can probably send a paste command to this specific box. Maybe I could, like, let me see if I take this value. Can I use this dialog to paste there? I can. So as long as I have this selected, as long as I send it to this specific window, I should be able to send that event. And that's one issue that our fuzzer currently has, is it's not sending messages to all the sub windows. It's only sending them to the parent window, but that's fine. So we're going to identify what this box is. We're going to see if we can get the handle to that box. I feel like that might not have been possible if I remember correctly. So we're going to open up Spy. We're going to take a look at that box. And basically we want to find a programmatic way that we can send a paste message to this location and control the contents of it. So if we look at this edit box properties, everything's about to crash, I think. Let me check on memory. What's going on? What's going on? What's going on? What's going on? You guys can still hear me? Switch to this quick. Oh boy. Okay. And I want to go here. So, I don't think I lost you guys there. Spy seems to sometimes freeze up like this. I just closed it. It seems like Spy might have bad interactions with Windbag, so I'm going to keep Windbag closed while we're working with Spy. That's the only thing that makes sense. So we're going to hover over this. We're going to find that this is the control ID E2. So we should be able to take the parent window plus that control ID to potentially get the handle to that. Or maybe we can just... Yeah, I think we're going to need that handle. Spy shits itself with OBS. Yeah, I could see that. Okay, so basically we need a way of... Honestly, there's probably just a message we can send to get A's in here. Can we just send a paste thing? I wonder if there's a way that I can send a message to the control ID. Let's see if there's like wind from control ID. Control ID from its handle. Yeah. Yeah, I don't think you can go from control ID to handle. That just wouldn't make much sense. So what we're going to do is... I don't know. Does anyone else have an idea for ways we can get grooms in? Obviously, we can figure this out. We're just going to have to... I'm trying to find the fastest path. I know a way that would work, and that would be like enumerate all the windows, find the one that's the text blocks, and actually do the right thing. But I'm trying to find a faster way to implement that, and there might not be one. So let's see. And if we paste into the main window, it doesn't work. Basic worksheets. So all of these we should be able to paste into. Child window from point. That's going to be pretty difficult. We could try that. Basically, we'd pass it the parent. We might actually need the correct parent. We might not be able to do like just give it this point. We might have to give it like the sub frame and then find the sub frame and then find the sub frame and then find the then do this API. But this is definitely in play. Let's see. We could also send a command to cause the calculator to change and reuse snapshot once it has like unit conversion open. We can make sure this kind of always exists, and then we can do the expensive process of enumerating for this specific window. So if I peek at this, we see that this is an edit class. Honestly, anything that's an edit class, we should be able to send a message to. See if I can do, like, that's a dialog, calc frame. Let me switch into basic mode again. Let's see if we can find an edit frame. And I don't know if there's going to be one. Let's see if there's like a send message paste. There's a WM paste. So first, let's see if we can get WM paste to work. Let's find like a certain way that we can paste into something. Not used, not used. So that's just going to paste from the clipboard. Makes sense. So we're going to have to populate the clipboard with something, then send a command to calculator to paste. So if I open up unit conversion, we look at, if we spy on this box here, and we look at the messages for this. So we're going to synchronize, right-click messages. And what I'm going to do, spy is going to freeze. Yeah, something about messages doesn't like. Okay, we're just going to have to do it blind. You guys probably froze up again. So frustrating. All right, we're going to have to do this blind. So what we're going to do is we're going to use our... We're just going to repurpose this. We're going to attach. We don't really care about deleting reg keys and stuff. We're not going to send any commands. We're just going to attach to that calculator screen, and then we'll do a Kaga run on this. I'm going to change kind of the size of this so we see what's going on. Okay, so I sent those commands. What we're going to do is print. This is going to enumerate all the windows. We just want to see... we could hard code the window handle potentially. Nah, we'll try and do this correct. Maybe. So we're gonna go through, and we know that that box, we can actually get the handle to that by using some sleek magic. So I'm gonna hover over this. We're gonna look at the properties. We're gonna see that this is control ID E2. We're gonna go through for window in primary window.enum sub windows. We're gonna print the window. And looks good. Cargo run, blah, blah, blah. Enumerate. Man, I typed it out. Enumerate. Good. Not an iterator, dot iter. Okay. And what we want is the E2. There should probably only be one E2, so we'll say if, right, it was E2? Yeah. If window dot what do we call it? Window ID. If window.window ID is equal to sum oxe2, then we're going to print out that window. Hopefully we only see one line print here. If we do, we found the handle to it. Yay, we did it. Now we can do window dot paste, and we'll just implement that in win bindings. Win bindings, we're going to find the WM paste, which is this. Paste is equal to this. Sends a paste command to the window. We're going to call this a clipboard. Down here, we're going to do this. Send message, paste. Attempts to paste contents from the clipboard into the window. We're going to send a paste. No args are used. Good. All right, what do you think? Is it going to work? I'm going to put 32 in my clipboard. All right. So now we need to figure out how to interact with the clipboard programmatically, because we're going to need to send, we need like full Unicode control, because we're going to want to send like arbitrary things. I don't know if the clipboard allows us to have like arbitrary things. Data is only inserted if it contains CF text. Okay. Please don't be null terminated. I'm curious if I can get nulls in the clipboard. CF text, clipboard functions, set clipboard data, format, standard clipboard formats, CF text. Text format, each line ends with the CRLF, and null terminator signals the end of data. Shit. Shit. Handle to HMEM, handle to the data. How do we set clipboard data? Copying information to the clipboard. We're basically going to get random clipboard pastes along the fuzz stream. We're going to give like a pretty high chance of that, and then we're going to see if any crashes pop out of the fuzzer. With that, we got 320 workers still running. God, that's crazy. What a world we live in that I can just spin up 320 fuzzers. Like, I remember when I first got my first like dual core machine, and that was a big deal. It was like, holy shit, threads actually can run alongside of other threads. Obviously, everything crashed because not much was used to it. So we're going to do an open clipboard. We can do a global alloc. Global lock. We'll unlock. So we need to allocate a memory object. Oh, it's not actually a handle, it's just a pointer. Okay. Well, that's not too hard. Do we just do this then? Do I need to close this handle? Nope. We're gonna do format U32, mem usize. So return usize. We're actually gonna do this down here. We're just gonna hack something up real fast. We're just gonna panic done this extern system unsafe set clipboard data. I just don't want to polish this code until I know it works. CF text is just one, and then we're gonna pass it a pointer to a byte stream that contains apples. We're gonna manually null terminate it. And it's only ANSI text. I bet we can do Unicode text. I wonder if we can do like a bitmap or something like that. So we'll see what we can do. But this is going to send standard text to there. We're going to print the return code. Okay, here we go. Yep. Expected usize found reference dot as pointer as usize. Okay, U format's in my clipboard right now. That returns 0. Let's see what this should return. If it fails, it returns null. Okay. Let's just find an example of this. Unless I need to do open clipboard. Maybe I have to. Why would I have to open... Why would I have to open the clipboard if I'm not going to use that handle for something? Okay, whatever. Handle to be associated. If it's null, it's associated with the current task. Beautiful. So we're just going to do this. Function open clipboard. Owner usize returns a bool. So we're going to assert. We're going to assert that we can take ownership of it. And then we're also going to want close clipboard. And we'll just do this. So we'll open the clipboard, set the clipboard data. We're going to assert that both of them succeed. Let's go. Holy son of a bitch. How is that heap corruption? Let me guess. This has to be placed in the global heap as movable. Okay. Son of a bitch. Assholes. What about the HTML clipboard format? What's this? Gross. Why does that exist? Global alloc, mem movable, that plus the null terminator. Okay, so we're gonna need this. Boy, this is gonna be a lot of code just to get something in the damn clipboard. Do we need a global lock and unlock it too? Oh my god. Killing me here. Global alloc flags, U32 bytes, U size. This returns a handle to the global. What did it do? It did that, and then we do a global lock. You think you could make this a little fucking easier, right? Global lock. Mem, usize, returns to usize. Technically, it returns that pointer. We'll say I'm U8. Global unlock. That takes in memory, it returns a bool. We're gonna treat this as a pointer too, just to make it opaque. And we'll make this pointer, and then we need global free. I wonder if it's so it can get the size of it. Maybe we can put nulls in there. That will free, mem. That returns a global. If it succeeds, it returns null. Otherwise, it returns the global. Okay, that's stupid. What? Come on. Global alloc. I don't know if we need the movable flag. Let's see if this works without it. We're going to allocate 32 bytes. Let global is equal to this. Assert global is not equal to 0. Let's double check that that is correct. If it fails, it's null. Okay, and then we're gonna do global lock, global let pointer is equal to this. Then we're going to assert that the pointer is not equal to null. And then we can do standard mem right pointer 7. And then we do global unlock on pointer. Assert it's true. Then we'll do global free on global. And this one, we want to assert that it is null. Stupid. Technically, we want to lock it, unlock it, open clipboard. Then we want to use pointer here. Okay, incorrect close. Here. Standard pointer rate. Right bytes. So this is memset, right bytes. I don't really want memset. All right, we'll memset it for now. We'll just do right bytes. Into the pointer, we'll write OX41. We'll write 7A's. No. Oh. It looks like everything was supposed to succeed. Why don't I have that in my clipboard? Lock, copy, null, global unlock. I guess maybe it does need to be movable. 2. Nope. And all right, let's see if I did everything right. I guess this technically opened the clipboard first. Shouldn't matter. Open the clipboard. Fine, we'll do empty clipboard too. Hey! Okay. I don't think we need the movable crap, so we're going to change it to bees. Okay, yeah, don't need the movable. This looks good. So open clipboard, empty clipboard, allocate, lock, unlock. Now I'm curious if the problem was empty clipboard. Dot as pointer. See if this works. No, that just crashes. Oh, I guess set clipboard data freeze it for you. Then wouldn't that fail? Wouldn't that global alloc set clipboard data? Oh, that makes sense. I guess you have to move that allocation. So I guess the two might be important. So then we probably don't want to free it, but we do want to close the clipboard. So open, empty, allocate, lock it, write, unlock it, send it off, close the clipboard, and I guess that will just get like moved maybe into the operating system. I don't know if that's a leak or not. Done. Paste bees. And now let's see if we can get some nulls in there maybe. Write bytes for 2, write byte. That's right, 1 null. Nope. Yeah, we passed the global pointer. Oh, shit. Well, I mean, it works. But yeah, that's definitely more correct. So, thank you. Thank you for that. I missed that. Global. We lock it. Put stuff into it. We unlock it. We set that as the clipboard data. We close the clipboard. And that seems to work. It's 32. Oh, that's just uninitialized shit. Because allocators don't zero out their stuff, because that makes sense. Global alloc 0 point, initialized to 0. We'll just do that. Nice. Paste. Bunch of bees. Okay, and now the question is there any way that we can get a null? Because if we don't have a null, we could never write a pointer. So we need to figure that out pretty badly. What's set clipboard viewer? No. Register clipboard format. Why? Why? Okay. Handled to the specified format. What's our registered clipboard format? Can we just make our own? Let's just see if that's a solved problem. Null character. Whoop. Null character. CFRTF. Ooh, that sounds fun. Let's see what we got. Standard clipboard formats. Bitmap, this containing that, followed by bitmap bits. Oh, software arts data interchange format. I'm glad that's there. Text display format associated with a private format. Meta file. We might be able to do this, maybe a bitmap. Although I don't know if I'm going to be able to paste that. So let's pen data, riff, text, symbolic link, a TIFF, Unicode, null signals the end. because we saw the like message, the paste, the Debian paste, it said it only accepted ANSI. It's only inserted if it contains CF text, but I might not care. Let's see what happens. So we're gonna paste, we're gonna find those A's. So we'll do cheat engine. We're gonna attach, oops, not to itself. We're gonna attach to calc. We're gonna close spy. We're gonna grab, that'll be a unique string. Paste. Cheat engine's frozen. Oh. Everything wants to freeze today. Attach to calc. Maybe 8.0 will work. And then for scan. Here. Copy the address. Attach. Calc. Go. Heap PA this. Son of a bitch. Heap PA OX2 362BDE 2F80. So this is where it allocates. Does get clipboard data. I think we're going to be curious into the invocation of that. We're going to put a breakpoint on that. We're going to see what it looks like. DPS. So get clipboard data. I just want to see how they're using this. They might be passing flags that are like, only give me text data or not. So get clipboard data. Format. So this is going to get it in the D format. And the D format is probably Unicode text. Yeah, it is. So this is explicitly getting the text as Unicode text. There's no way to have null characters in this. So we can at least try this. We can just spray a bunch of 4-1s and this will tell us if it's possible to deref 4-1. So we're gonna try that. So here we're gonna switch to mode 13 or OXD. And now this is Unicode. So this should be 6. Let's just do this, 44, and we're gonna do 512. And actually, we'll just do, yeah, 44, 512. I'm gonna get that in the clipboard. Looks good. I'm gonna paste. And I guess get clipboard data, that probably just returns a pointer to it. So let's just see. Maybe I can just paste, return DPS racks. Nice. So that is a way that we can get arbitrary contents in, but it can't contain a double null sequence, which means we can't make a canonical address. But we still can make densely packed arbitrary memory within the Unicode UTF-16 encoding limits, which are pretty friendly. So what we want to do now is we want to modify the application that we're injecting into, we want to change the application that we're running in our fuzzer. So let's check in on them, see where they're at. We got a new crash, right user. This is probably another stack exhaustion, CR2, yep, stack exhaustion. Not a big deal. So what we're gonna do, inject ID. So we want to make a format that allows us to kind of Somehow we need to indicate a paste command. I think we're just gonna hijack a command so we don't have to rewrite our like serialized protocol. So we're gonna do some cheese. We're gonna go into inject ID. This is the application that we're running inside of TKO. We're then going to say if command is equal to OX okay. We're going to say if the command is equal to 4548F1E8. This is the special. That means we want to do paste. Do a paste. A pat. Do a paste. A past. We're struggling today. Do a paste. We're going to take all this shit. Actually, we're going to make this even better. So I probably can't paste because I have this open. Yeah. I was like, why is my clipboard not working at all? Makes sense. So we're going to do a paste here. We're going to take this. We're going to tab it in. Since this is specific to a target, I'm not really concerned about the code quality anymore. If this were a generic fuzzer, I would try and clean this up and put these in nice places. But I don't really care in this case. So what we're going to do is we're actually going to look for this. If command and OXFFFF0000, then we're going to do size is going to be equal to command and OXFFFF. We're going to assert that size is less than or equal to 4096 just to make it sane. Then here we're going to take size plus 2 because we need to null terminate. Actually, let's just put size plus like 16. So we're just going to overkill the size just to make sure it really gets padded out with nulls because we don't know what the last character will be in for the... Oh, actually, we're going to send A's so we can do this. So we're going to allocate size plus 2. Then we're going to write a for1 for size bytes. And since we have that zeroing out, that will get zeroed. So we'll allocate up to 4K bytes. If size is equal to 0, continue. That way we don't do like 0 byte stuff. And then this we're gonna do, yeah, size plus 2. Yeah, we will plus like 8. Because we're going to allow it to give like an arbitrary number of A's, even though it has to follow UTF encodings. So we're going to write size for ones and a buffer that's 8 bytes larger just to be safe. And that gets zeroed out. We're going to pass that. We're going to set the clipboard data here. And then we're going to close the clipboard. To deal with the null bytes, is it cheating to spawn the calc process, get a handle to it, and use WPM to write some null bytes? Yeah, I think right now that's cheating. If we can't do better, then we'll probably lax our restrictions. So, okay. So we set the clipboard data. So this will set the clipboard to contain these things, but then we need a chance of sending a paste command as well. And I'm going to see if I can send a paste command to the global window here. So what we're going to do is in our inject thing. Where is it? Don't need that. Don't need that. So we're going to slightly modify this just for a test. We're going to set OX30s. Which is just zeros. Actually, we're going to set ones. We're going to do 8 of, we're just going to do 4 of them. And then that panics and does done. And we're going to do a, we're going to try and send a paste command to the primary window. And then we'll see if that works. Otherwise, we're going to have to find a dialog that we can paste in. which is fine. We can totally do that. We can add this enumeration. Fuck it. We're just going to do this. We know this works. So we're going to set up the clipboard. Then we're going to... So we're going to set up the clipboard, open, empty, allocate size plus 8. Then we're going to fill it in with 4 ones. We're then going to set that as the clipboard data as Unicode. We're going to go through all of the sub windows. If it's equal to E2, which is this from dialog only for conversion, then we're going to paste. I mean, I guess we'll try. If we can send it to the primary window, the problem is we're not selecting those boxes. I don't think. So I want to see, where is it? Primary window.paste. Oops, we don't want that. Up here. Primary window.paste. We don't have any of this stuff open yet, so we'll move this down. We're now here. Primary window.paste. See what happens. I bet this is going to work because I have the text box currently selected. So that indeed did not work. I think maybe if I had focus, it would work. But apparently not if I don't. Okay. Let me see if there's a way I can select a window. Like WM select. Actually, the WM command might be it. So we can do primary window.command oxe2. See if we can set focus to that. We cannot. But if we get rid of this panic, we should see this paste into that box. But if and only if that box exists on the screen. Really? Oh, we hit the breakpoint. Okay. Yep, that works. Let me double check. Primary window dot select or dot command oxe2. Message select edit box. Music's getting intense. I just don't know what command is sent. Maybe we can find the API reference and find what looks good. I'm guessing like WM some strings. No. Menus. Cursors? WM set focus. Thank you. We can do a WM set focus. Focus. Send the set focus command to a window. Oh, but that we're not going to be able to give an ID. Yeah. Yeah, we're going to have to find it. But if I do... Oops. Guess we already have it open. So, what we know is that we can just... If we search and we find one of those, we can do a paste. Yep, that works. Looks good. Global free we can get rid of. Okay. Clean. And that was sending... Oh yeah, that's not valid. So if we do this. Okay, and what I want to do is I want to see if I can get the C values to show up. So we'll take a look in this, and I'm going to search for CCCC, non-UTF. We don't see it. This should hopefully cause C's to show up in calc. Son of a bitch. We know the 30s work, right? This is going to send zeros, 4 zeros. Or 0, 0, 0, 0. Oh, I was passing 4 and searching for 10. You know what? Thank you. We'll pass in 128. How's that sound? And not 4C, 4-3. And these will be capital C's. Okay, doesn't exist. Run. Good. New scan. First scan. Nice. So that definitely works. So this only will work if this window is active. But you know what? That's good enough for us. So now we can go back into this. And yeah. Oh, is that everything? Yeah, it is. So we set the clipboard data to size for ones. The size is determined by the command, and the command has just a special top 2 bytes. If the size is 0, we do nothing. Otherwise, we set the clipboard, allocate some room, and then we send that command, but only if we can find that dialog box. If we can't, then nothing happens. What we should do now is figure out all the other boxes that potentially could be written to. So we can make a set of like all the pastable things. I mean, we can honestly see if it works on like the primary box. Because if it does, then we're in a really good spot. So let's see if we can send it to. Oh, that's control ID 0. Oh. Like, what happens if I send a paste command to that, to 51, which is just a button. Oh, it's 51. And now we're going to send D's, which we shouldn't have. Okay. Okay, that did not work. I'm just using calc and it's crashing now. Unless I had the inject counter? No. Nope. Nope. Nope, that just crashes. On custom commands, assemble dialogues without toolset, set window pause. The D's are too strong. What is this? Oh, uh-oh. That's a use after free right there. That, my friends, is a use after free. You son of a bitch. Calculator. Doing calc shit. Does that always crash? No. Okay. So I guess the D's didn't work, right? Yeah, we didn't find it, but then it crashed when we like closed it or some shit. So we could find, I don't know, we could just send it to a random thing. Making an insane poster just to have calc crash randomly. Yup. We're not even sending random messages. We're still sending only like clicks. If we sent random messages, we would probably be flooded with bugs. But that's a little bit less fair because I think if you can cause a crash by sending an arbitrary message, I don't know how realistic that is. Like, the goal is I would like to make this where it's a user doable thing, like something a user could click through. Well, not a human, but like in theory, it's just inputs. So, because if we sent arbitrary commands, I think we would just win. What if I just send the... I'm going to do this. If this is equal to 4, 1, 1, 2, 3, 4, we're going to have... Okay, then the command is going to include where we write it to. So let's say the size is equal to that, and then the WID, the window ID, is going to be equal to command and OXF123 shift to the right by 16. And now we're going to send it to whatever window matches that window ID. Up to 255, which should be fine. I think that's acceptable. All right. Yep. Now on 32-bit, this would likely be exploitable, but on 64-bit, we're not going to be able to get the double null needed to make a pointer. So we can always downgrade to 32-bit and try and make it easier that way. Copy, inject, source, win bindings to source, win bindings. Yes. Done. Global free, we don't need buy. Okay. Go clean. And then let's, I guess we can take these workers down. Man, we're getting to that point. Okay, looks good. All those workers are exiting. I just want the workers to exit to make sure that, and then this, where was it? That was deb-fi. Archive. Okay. Sweet. That means coverage should get saved and everything. I'm actually we're going to start with a new database because this database we might end up kind of ruining. So what we want to do is crash results. We'll go into stream fuzz after modfix. Then we're going to go and yoink all of these, and we'll yoink just the coverage files. Okay. I'm going to delete these because we don't need them. We will need calc. So, okay, so we've made a copy of all of that, which is good. Now we have modified our application, so this should fail to build because that file doesn't exist. Build release. So this means this file is what is going to get injected instead. Okay. And I think we also want to put a print in here. I'm going to close that. And here we're going to do print posting clipboard X to X. Honestly, do we just paste to all? Yeah, it's a fucking fuzzer. We can do whatever we want. We're gonna just paste to all of them. Now we don't use WID anymore. 4193. Posting clipboard to that. Well, now we know. So this is just gonna post it to every sub window. That in itself might crash and cause us to never see something. So we're gonna keep our eye on that. And here we're gonna say like print did a paste. Sweet. so now that's in there, we're gonna have to re-keyframe it. Cargo run start calc. We have to modify this to be in true mode. So this will re-keyframe it with this new binary in there, so it will update the binary in the snapshot, in the keyframe. Okay, we got calc step now. So now we can run the server, and the server would deploy it with this state. I think this code should be fine. If it's not, I'm going to blame you guys. So then what we're going to do is we're going to put generate, and I'm just going to like input.extend from slice. This is just to be a test. I just want to make sure that this does go through. If I put an F here, we should see a panic.to LE bytes. 32. Okay, I just want to see if this panics or not. Cargo run start calc repro or calc stepped. Attempted to queue up another agent command when one was pending. Yep, we figured this problem out before. I was like, man, I know we've solved this problem. What is it? It's the re-keyframe. So oops. Okay, and what are these saying? Did I send that in there correctly? 4193 FOO. Process exited with that. Francie gave us that. Is that crashing? Because I want to see a did a paste, right? We're not seeing that. Maybe it really is crashing. What was the filter on E2? We're going to temporarily put that filter in. I'm going to need to add a way to make this dynamically done. This is getting a little tedious. Okay, made calc stepped. Do we ever see a did a paste? It's always exiting with a 101. Is that the assertion? Oh, is it because we don't give it a string? Foop. Yeah, maybe the assertion isn't giving a string. Okay, we'll put in a valid thing then. We'll put in a valid size. And did a paste. Okay. OOFO. So this will be 256 bytes. Did a paste of this, and or 255, I think I did. This will be size. Enumerate. Blah. Oh, we didn't build this. I'm gonna move that to another monitor. Okay, we gotta make sure we resize it. Okay, so we have a way of build that app, go through, close some of these windows because it's starting to get overwhelming. Don't need that window anymore. Don't need this window anymore. Don't need that window anymore. That one we do need. Okay. So we built it. Here we're just going to say invalid size. Build. Then we're going to run over to this. Got to put this back into true mode. Yeah, I know. Then we're going to go into false mode. And we're going to run calc stepped. Got to crash. If they crash, we're not going to see the print, because it's going to crash before the application exits and the agent calls back up. So I'm going to put this on quiet. I'm going to take a quick break. I'll be right back. All right. Okay, did a paste to 255. That looks like that worked. All commands sent. Nice. So it does seem like the pastes do correctly work. It just needs to get through through without crashing. So we've got the paste. We're sending a bunch of A's. Now what we're going to do is we're going to slightly modify the way that that we handle crashes. This is in plugins crash handler source lib. And when we go to format the crash string, what we're going to do is instead of classifying page faults with the crash type, we're just going to directly put the address in there. Faulting address. So this is going to be temporary. XXXX hack. I think that's even going to produce a warning, which is good. And then this, we're going to put a little X on there. Do this. And this is typically the crash type. I just want to make sure I remember to remove that in the future. Okay. Oh, it doesn't like that at all. Damn it. Alright, we're just gonna have to remember. It'll be pretty obvious. We'll remember. Oops. Okay, and then these are gonna go into crashes. I just want to see. Yep, so B0, that's the faulting address. And now we're going to change this to hex B0. And I think we're ready to ship. So, oh, we need to allocate in a reasonable way. Oops. Well, that sucks. Oh well. So we'll go down to here, and what we're going to do is we're going to say if franzia.rand mod 32. We're going to have a 1 in 32 chance of putting in a paste command. So this will be the paste command. I guess we need to pick a random address. Select a random command. We're going to replace it. And replace it with... And replace it with a paste command. And... Okay, I need to go grab that thing. I think it was 4142. 4193. Okay, we'll do a paste command. U32 or franzia.rand mod 4096. So this is command is going to be equal to this. Fuck, I put it in the wrong spot. What am I doing? So the scrolls are really weird if I have this full screened. Mainly because I have a monitor with a different DPI. So I gotta do this. Okay, we got the command here. We're gonna pick a random selection. Do this. Select a random command and replace it with a paste command. Input cell is equal to CMD. Rand mod input length. We're going to generate a command. We're going to OR that with franzia.rand mod 4096, which is the max length we allow for our little groom thingy. 4096 even is pretty huge. Okay. And then I guess we're going to start deploying it out. Remove the inputs. And what did we do? I think we had this filtered on that specific dialog box, so I'll be curious if we ever see this come through. We're going to spin up the 64-core server first. And now, don't have any crashes yet, but these crashes will now have the actual address. Aren't I overriding the command in the mod 2 case? Yep, I am. Yeah, technically 1 in 64. Good enough for me. It's not meant to be a specific number. It's not a big deal. It basically ensures that it'll happen like a couple times per input stream. So now we get to see all the different ways things can crash. Hopefully this doesn't become an overwhelmingly large list of things, but it might be. But this is where you want to see if 4-1s come into play. And if 4-1s come into play, then we might actually have some real bugs. Gave us a paste of 2788, so it is doing the paste stuff. More cores? Nah, it's fine. It's fine. I think I want to change the size of the random allocation. I think the FFF is just too large. The odds that we do a paste command and it's in a reasonable boundary, I think are pretty low. Because most of the objects will probably be under 300 hex. So that's what we're going to do. We're going to change that up a little bit. We'll modify this to go up to OX 300 instead. We're going to drop this. We're going to make this more frequent. And then we're going to re-keyframe. Because I want to see if... I want to see if there's any way that we're able to... Let's see. Send to all the windows. Where is that at? So here we're filtering. I'm going to turn off the filtering. This will increase probably the success rate of pastes. We don't even know if a paste has occurred yet. I guess we could look at the paste coverage stuff. So we're going to need to re-keyframe again. It's really only an issue, this re-keyframing stuff, as we modify that application. But once we kind of have a rigid idea of an application that does everything we want it to do, we're kind of set. So now we'll do all of these, and we just got to bring some cores online. Okay. Come on. And crash this folder. We'll just delete it just to get a good like comparison. Okay. Now we're probably going to see a lot more paste commands. Because we made it 1 and 4, which is actually probably like way too many. I'm actually not seeing any of the paste commands. Am I? Paste command, that mod 4 is equal to 0. I'd expect to see a lot in the prints, but we haven't seen one yet. Okay, if we haven't... Oh, did a paste of 760. So, like, sometimes it can paste, I guess. So, the 2A, 5A5. Okay, we got a D crash. See what this looks like. Dereffing 30313131. We might need to somehow... I don't know how we could get the faulting register in there. That's actually a really hard problem, which kind of sucks. I've got some Pocky here. Sorry. So if we do that, 28, I think I might be able to add enlightenment into box for specifically non-canonical accesses, so I could actually borrow the address that was passed to box, such that I would have perfect knowledge of that. Is a hack that depends on inputs not possible by a human considered valid? Yeah, I mean, we're making our own definitions in this case. So whatever we say goes in this case. Generally, there just won't be human interaction in a crash or in like an exploit. So yeah, you could kind of argue that. I think sending to all windows is screwing it up. Oops. Yeah, it's definitely a legit bug. Regardless, all of these things will be bugs. An application can never crash. There's never a situation where an application can crash and it's not a bug. It's just doesn't matter in any possible way. If your application cannot handle inputs, even if that means I'm sending arbitrary messages to your application, it still means they are not handling those messages correctly. So we're gonna do a, what do we want? Rekeyframe. We're gonna modify this application to have the filter back in. It's not great. We could find more text boxes, but I don't want to do that right now. Okay. Run a server. Let's go. So now we'll see a lot more frequently that it should paste. Almost every single one is going to have paste commands. Once they get spun up. We should see a lot, like almost all of them will have paste commands now. Did a paste. I'm actually surprised. It seems like we're not seeing too many pastes. I wonder, is that paste like crashing us a lot? Oh, did we not rebuild? We didn't rebuild the application. God. Yep. Okay, this true. Set this true. Okay, build. Rekeyframe. False. Start server. Connect to server. Starting to be too many steps in this process, which is increasing chances of mistakes. I should automate it soon. Why Windows? Why not? Works great for what we're doing. So I don't really care. I don't affiliate with an OS. I'm just going to use whatever works for whatever situation I'm in. Okay. And I want to make one more change. I want to print in here only when... I want to print in here only when we actually do the paste in this. Did a paste here. So now when we see did a paste, that means we actually were able to send it to a window, which means we were in the right mode to do that. This will also verify that indeed the window mode is changing, because we don't actually know whether or not that's happening. Without a sleep, there might be a chance that we're not doing that correctly. Rekeyframe is true. keyframe is false. Delete, run server, connect. I don't know, I don't really care about Windows or Linux. Doesn't really mean anything to me. I use Linux in some environments and Windows in others. I can use both just fine. Neither of them really inhibit my ability to do anything. Okay. Lots of crashes. Haven't seen any pastes yet. Pastes are going to be relatively rare. We're only going to see them if the application exits successfully. I think maybe one of those I saw paste. I'm not sure. BO 10. Did a paste of 302. So we are actually doing pastes. How do you like Rust for doing this kind of work? It's the only language I think makes sense for this kind of work. It's just like, I don't know. Like, it's really hard to write fuzzers in C. It is. Like, your goal is to write something that corrupts the shit out of an application, and you need to somehow do that perfectly yourself. All of your offsets, all your calculations, all of your mutation strategies, generation strategies. You basically have to write parsers that are better than the application that you're fuzzing, because you need to be able to parse the inputs that you're sending to it such that you can modify them in a meaningful way. And that's a very tall order, I would say. Did a paste. We only saw one did a paste. I guess the odds that these applications crash is so high that maybe you think it's struggling to like get all the way through. But we see all the addresses now. Probably biased, but Linux has a better terminal. Yeah, definitely has a better terminal experience. That's for sure. But like, it feels better, but it doesn't really speed up or slow me down. I definitely prefer it if I'm doing terminal style things. So now we're just waiting to hopefully see 4.1 show up. Otherwise we need to get like a use after free. So if we want to actually try and land this cleanly, if we want to do, what we effectively need is we're accessing out of bounds during a type confusion for a pointer when we go through and like use the repros that we have locally. And when we do that, let's double check this one quickly. This one's dereffing complete garbage, because I think it was RCX. Yeah, this one's dereffing just complete garbage. So the problem is these won't get deduped, and this is where we'd see like a full 4.1 smash. So how would I do that? In a GPF, what could possibly reflect what's being accessed? I need some way of getting that value. I don't know how I'm gonna get this value. I could do it if I modify box and add a new fcall or a new crash, but shit, that's a lot of work. Is there a better way? Is there an easier way? Or a hackier way? Because we're just not gonna see it if it comes through as a non-canonical. I don't know. Let's take a look at like a canonical address check maybe in box and see if we can snake that through. Means we're gonna have to build another box and re-keyframe and everything, but if we're quick about it, we can do it pretty fast. Okay. Canonical, non-canonical. Those are VM issues. OXD. Yeah, that's gonna be too common. I need something to search for because I don't know where in box this is implemented. General protection. Yeah. Okay. GP. GP misaligned. GP not allowed. It'd probably be in the memory stuff in the page table walk. Access 2, here we go. Misaligned maybe. On GP. To do that, we're gonna search for this. So problem is general protection faults are used everywhere. So grepping for this is just gonna lead to everything. Paging, here we go, it's here. Ah, that's a priv check? Really? Shit. Exception. CPU. Maybe an access. Misaligned address. Where did I find this? Canon. Non-canonical. Canonical failure. Here we go. If it's not canonical, there we go. That's nice. Then VX error. If it's not canonical, then return with a that? That makes no sense. C tags r dot. Why would it return a BX error? How would we get that to return access rate linear? My music taste is odd. Yeah, we're just chilling. I can change it up if you want it changed up. I can change up the music if people want that. I was just trying to go with something that's easy, chill, relaxing. That's in paging. We're gonna take a look at access 2. Exception int number s. Tickle read linear. Is this what happens? I feel like this is probably only used a couple times, right? But that makes an exception. Never understood why people put music on stream. It gives a commonality between everyone who's watching, so people can communicate and like share that, have that in common, discuss the music like we did now. If I weren't playing music, wouldn't have that like commonality. Also can be used to like get the streamer's ID, like taste. It's like another way of communicating. But no, I normally like to listen to my own music, but I think it's nice to be able to have music coming through the stream. I think there are benefits to it. Tickle read. Like, I don't think it's using these tickle reads. Like in paging. Paging would make sense. Paging would make the most sense. But the fact that they're returning an error rather than an exception. Because I need to see it generating those faults. And I think there's like a read virtual. I mean, we can just see what happens when we read virtual memory. Tag read virtual dword. It's a macro that does read linear dword. If is read okay. Oh, if it's less than 0, then it returns an exception. But that makes no sense. Read linear dword passes an S. Write virtual dword. Oh, that's the segment. So it passes in the segment. Oh yeah. In number S. I'm really confused. Read virtual quad word takes in an S. If we look at things that call read virtual quad word, they pass in the segment. That would make sense, I guess, if exception was the parameter for the... Okay. Ah, it's going to raise an SS or a GP. Okay, that makes sense. So then this, if it's non-canonical, access read linear. Okay. Now what we care about is canonical failures, or pretty much anywhere in paging that probably implements this. This one I don't think we care about. Nope. This one we do, so write linear. That makes sense that this is where the check is done. And then, what could I do here? I could do a, I could put it in CR2. Like, the processor doesn't do that for you, but I could put it in CR2. Technically, that's a change to, like, what the guest could see, so I don't like that too much. So I think F calling it up is probably the way. We're gonna do F call, canon failure, and then we'll send it the address. So this will give us kind of enlightenment into canonical failures. For second half of page cross split, looks good. This, don't need it. This one we do. This one we... And let me add if... if def Franzia, just to clean it up so that doesn't get sprayed around. And then we'll do ladder 2 in this case. And then in the first one, this one, we're going to change this here to be linear address. This one is linear address 2. This one's going to be linear address, and this is in read linear, which is good. And we could also say, like, this is a read. And then this one is a write. Might as well. We have that information. We might as well pass it up. Okay, ladder 2. Then here, we have ladder with a 0. And then this also. Ladder 2. Okay. Okay, so all of those have been hooked in paging. That should get us pretty much everything. And now we can special case that. Obviously, this is going to fail to build, but we're going to go whistle cd Franzia box build, and I can just do a cat. Actually, we're going to do a copy of build.sh to configure and build.sh. We'll modify build.sh to not run the configuration. Yeah, we're not going to be able to do that here. Never mind. The way I have some stuff set up is going to make that a pain. So we'll just do build.sh. That's going to fail because we haven't defined an fcall canon failure. Put that in box.h. We fcall canon failure. Allow us to get that address all the way up. Okay, and that should now build. Looks good, looks good. Right. Canon failure 0 on a read. Canon failure 2 on a read. Looks good. Once this is built, we're going to have to... I'm just going to have that up on another screen. As long as that succeeds, then we're going to be able to go into shared plugin source. Oops, shared libtko source lib, and then in here we're going to go towards the top. Yeah, I know this is not wide enough. Kind of gross. We're going to give this a passable out of 10. And let's go to fcall startup, fcall this, TLB change. We made a new one called 16. Let's double check. Box.h. Yep, 16. We called this fcall canon failure. Box did successfully build. Everything looks good. So copy box, mount d dev tko plus franzia box. Okay, so that's been replaced. We now have a new box that correctly calls up. And I think we could start reporting these as page faults then, if we're creative. So fc self.fc canon failure, and we're gonna put this next to here, and then we're gonna go to exception. Where's exception at? I think I do everything through interrupt in this case. So fc interrupt, then we'll have an fc canon failure. Need self this and access occurred. Wow. I can't spell occurred. Holy shit. An access happened at a given address, which was non-canonical. This caused a GP exception, and we're just providing the address and the read or write information for the crash. Okay, and we're gonna do a self.regs. We need to get the args. So we're gonna get the first argument is going to be whether or not, ooh, infernal crack lead. Welcome to the following crew. Let's see what we got. Looking forward to more of these streams. I've learned a lot from these. That's awesome. I'm glad. I'm just having fun, having a chill night. Nothing is too stressful here. We're gonna convert this to a bool, and then this is gonna be is right, and this is gonna be the linear address. And what we're gonna do is I think we're gonna just create new registers in our internal representation of a VM. So we're gonna go into shared libtko source. Nope, I'm so used to that muscle memory. We're gonna go into shared. We got a canonical failure. So we want VM source. I think just in general we want lib, reg state, implements these. We're gonna put it on VM. And we're gonna put in two fields. This is gonna be last canonical failure. I don't know. Maybe I can make this async and not actually put it in a state and have it checked. Let me see if I can invoke crash handler directly. Not unless I have crash handler use a special handler. I could generate an input, an interrupt. What is the RS extension? Yep, Rust. This is like the most retro idea I've seen. What even is this? It's just gvim. But yeah, I mean, I format to 80 columns, and this is why. Like, if you don't format to 80 columns, you can't have this many windows open. I normally use like a 6 to 8 point font. So if I do 80 column windows, I can barely get 4 across the screen. But in a bigger font, it still is allowing me to have a checkerboarded thing on one monitor. And one monitor, to me, is an unusable work environment. But for streams, you know, we get what we get. So I'm not used to only working on one monitor. So this is like a new development environment for me, which is kind of fun. So we're going to directly invoke these interrupt handlers, I think. In fact, honestly, yeah, I think we do need to put in metadata because this doesn't take enough arguments. We could make another F call, but then we'd have a lot of code duplication here. I guess we could do handle crash. Handle crash. Where's that at? Handle crash. Plump through a crash. That's a bug check in this case. So that's like special error. That's for a blue screen of death. So if we have an OX14 or a page fault, actually OXOE, not hex, but decimal. If we have a page fault, we go through and we generate this information on that. And notice that I don't full screen the CMD. It's so I can click. Makes it easier to switch between them. That's pretty much the only reason. If I had multiple monitors, I would have a full screen CMD, or at least always visible half split. But it's nice on one monitor. I've found that being able to click makes it a little bit more usable as an environment. Like I'm literally learning how to use a computer with one monitor. I'm not used to it at all. Okay, let's do this correctly. Let's not hack it in. This is a real code base, so let's treat it with respect. So we're gonna create a new callback. That's gonna be a special one that will go alongside of an interrupt, and this is gonna be called when a guest non-canonical access occurs. Did I spell occurs right this time? So, oh, I guess I had it. I probably saw it on the other line. Called when a guest non-canonical access occurs. This is when the guest accesses an address in 64-bit mode and the this isn't canonical. This typically generates a general protection fault. However, the GP does not carry information about the address or the type of access. This is special enlightenment from box directly telling us the address and the type of access that occurs. Okay, now you can do a function. This is going to be non-canon access. Mute self. It's going to take in a Franzia. We're going to pass it the linear address as a usize. And then we're also going to pass in a and then I also am going to pass in an isWrite to bool here. And by default, it's already implemented for you as something that does nothing. We've got linear isWrite, looks good. Okay, so we have that. That looks nice. Interrupt. So now I need to also make, there should be a field in an enum here. That is the reset reason. Here's the list of plugins. So we have a different list for all the plugins, so plugins can register all these different things. So non-canon access is what we called it. Yep. And then blah. Okay, for your plugin, non-canon access. So that's the enum that a user uses to select which one they want. And then this is where they go to actually add one. So this is where we do the conversion. Kind of sucks. I should convert this to use a macro. And that's probably what I'm going to do soon. We're going to be doing a code cleanup thing because this code base is starting to get really messy, which makes it kind of hard to work with. I think there's one other non-canonical access that I might need to look at, and it's going to be on execution. And I don't know. I need to see what happens if there's a non-canonical PC. So what do I want? You want is canonical? I'm gonna look for something that looks execution based. All these control yeah, these are probably it. Is canon. That's gonna cause a GP for all of these situations. Okay. I'm so tempted to just move on and not implement this, but it's so important to just do this shit right the first time. Otherwise, you'll be right back in it shortly after. 2 is going to be execute. Oops, that's the return rip. Grab this, smash it in here. We're gonna put this one in the clipboard in Vim. And I think I want the fcall to happen before the exception. Let's make sure that I'm consistent. because I want that to be consistently a thing. So in that case, it will. In this case, it will. In all of these cases, it will because it returns out. In these cases, yes, yes, yes. Shit, not in my buffer anymore. This is gonna be new rip. Hop down here. What am I don't know how I keep screwing up my buffer. Oh well, new rip. GP exception, new rip. So these are all of the like different instructions that can cause control flow in box. This is OP164. Okay. Okay, new rip 2, cannon failure. Return rip 2, cannon failure. Return to cannon failure. New 2, cannon failure. New 2, cannon failure. New 2, cannon failure. Op164, 2 cannon failure. Looks good. So now we should have execution stuff on that too. So we should basically be able to tell if the if it executes. So we need to go in and modify this in cannon failure. And we're gonna make this no longer a bool. This is now just a U8's fine. And then access type. And access type will be 0 means read, 1 means write, 2 means execute. Okay, get the linear address of the access. Then we're gonna go to non-canon access. We're gonna change this. This is no longer gonna take a bool. This is gonna take the access type structure, or enum. We're gonna make that quick. So we'll just go here. Looks. This is acceptable here. Pub enum access type read write execute, and then we're gonna derive clone copy partial equality partial ordering debug and hash. So that'll be good for pretty much what everyone wants. Type of access that occurred. Is it 2 C's and 2 R's? That's not right. I think it's 2 C's and 2 R's. Okay, non-canonical access now takes an access type. Then we're gonna do the conversion in FC FC canon failure, I guess is what we call it. We should make that naming consistent. Yeah. I don't know. This lines up better with box. I think I'm gonna side with box when we're doing kind of boundaries. So 0, 1, 2, we're gonna get the access type is gonna be equal to the access match. Access type 0 type read write execute. Panic invalid access type during canon failure. Okay, that should never happen. Now we have an access type, read write execute, 0 and 2, looks good. And now we're gonna want to invoke the callbacks. So this is what the invocation of callbacks looks like. In this case, let's make sure all the interrupt instances go away. Sometimes I'll typo and do 1 non-canon access. And then this is going to take the linear address and an access type. Okay, and then we'll get that success. I guess this one, I don't know if, I don't know. We're going to set this. I need to figure out what this is for. I don't think this is used anymore. I think that's a legacy thing that we don't need. Access type, convert it to RWX. Then we're going to pass this up to whatever plugin registers a callback. Pass in the Franzia reference, the linear address, and the access type. Let's make sure that lines up. Looks good. So this should hopefully be buildable. I copied over the box that we just built with all those new modifications from... I copied over the box with the changes for the execute callbacks. And now I guess we just see if we crash. I mean, this won't work because we haven't updated the keyframe. But I just want to see. Yep, looks like everything builds. So we... Wow, we did that first try. No warnings either. Fucking fantastic. Okay, now we're going to go into crash handler. We're going to implement a... We're going to implement another callback, and we're going to register for the callback as well. So here we're going to do fn non-canon access mute self. What are we trying to do here? What we're doing is we're adding in basically on x86 when you access an address that's like wildly invalid, it shows up as a general protection fault rather than a page fault, which means that we're no longer able to see what the address is or the access type. So what we're doing is we're adding a special enlightenment to box that allows us to see that information. So, and then that's no longer is right. This is now access type. And we're going to have to pull an access type from Franzia. Access type there. This is now access type. Okay, looks good. Good. Nice. So we're going to have to register for that callback. So we'll do that here. Non-canon access. Basically, this allows us to see the address that that is read during a crash. That's the really sophisticated way of mentioning what we're doing. So that expects a mute Franzia. Yeah, what did we fuck up there? You wrote Franzia? Yeah, I wrote a large portion of it, but it's a team project now. So a lot of the fundamentals, I'm kind of like the tech lead of it. So a lot of the design concepts and ideas line up with kind of what I would develop. So there's definitely some code in here that I have not written, and I can't take credit for everything that's here. So let's see. This is handle non-canon access. Oh, typo. Sorry, my bad. Yeah, I did. I just glanced at the text and I didn't see the typo. It's gonna be hard to correct me on typos because I'm probably just gonna read the typo correctly in chat. Got a non-canon access. This at x linear adder access type. This isn't necessarily gonna work right away, but okay. First, let's we got to rekeyframe. So cargo dir fake fs. We're gonna tear down the fuzzer while we're doing this. Cargo run keyframe this. So this will integrate the changes that we made into box into this keyframe, which is the base calc one access type. Got that. Wait, did I do this backwards? Yeah, I did. Yep. Method is never used. Where? Crash handler? Put it in the wrong spot. We didn't put it in the impl. Yeah, here's the impl. Boom. That's why having warnings as part of, like, clearing out warnings and keeping warnings down allows you to see stuff like that immediately told me a bug before I even went to build or run or deploy it. So I'm pretty picky about keeping warnings down. Obviously, we have one warning, but it's the function we're about to develop, so that one I'm leaving. We're just re-keyframing this, and then I want to see that we're getting this correct enlightenment and we're printing out when these failures occur. We can also check in on what crashes we're looking like. Where are our crashes at? Dev, TKO, Franzia, calc stepped. So here are kind of all the different axes that we're seeing. None of these look too crazy. They look to always be the same value, which would line up with a fixed type confusion that's not controllable. So I think the ODs, this one's kind of interesting, actually. So we're going to start calc. We're going to have to put this in re-keyframe mode. True. We're just doing this quick to get this tested. False. It's been re-keyframed. Now we can run calc stepped. I don't know. It's gonna take a while for it to find that crash, so we're just gonna implement it. We're just gonna get the whole thing right. Okay, so handle crash takes these arguments. We could add a special case for non-canon, or we could have, or we could specifically add like a page fault field. We're gonna try that. I don't know. What is the cleanest way I can write this? I want to write this in a nice way. So we can close some of these things that we're not looking at right now. So we need to handle some of these different modes. Basically, this code we need to reuse. And I could either treat non-canonical as a page fault and then just grab the addresses. So if it's a BSOD, otherwise if the vector is E, or the vector is equal to an OXD, and I guess that won't be the case. Or we'll say non-canon access dot is sum, and then we're gonna pass that information in here. Non-canon access option is the linear address and the access type. So now we have that information in this function. The problem is I don't know if I want to display. Yeah, that's going to use a page fault stack. I don't know if I want to call it a pound PF, because it's not actually a page fault. And that, like, while it would be nice to read it the same as a page fault, there's something about saying that a non-page faulting exception is a page fault, even though it looks so similar to it and everyone will understand what it means. I think it's just a level of information. It's a small amount of information that's lost in the file, and I don't like that. So I think instead what I can do is I can genericize this code here, and we're gonna move this shared memory expect format mod off. So if this takes in Franzia and the faulting address, so we want to provide a CPL faulting address is right is exec. Okay, we're gonna do this. VSP plugins crash handler source lib. Shit, now I lost my scroll position. That actually really sucks. Okay, non-canonical access. We're gonna paste this up into... We can just make a member function called, let's say classify access. Classify bad access. And this is gonna take a linear address. And it's gonna take an access type. And this is gonna output a string. We can also take in Franzia. And the Franzia is gonna allow us to get the lengths fast, or it's gonna, okay, so that's at faulting adder, good. I think I can fit that up there, yep. And then this one I can drop down to here instead. Okay, given an address and an access type, determine the type of the crash and the format string to use. And then this is going to be like subtype, and this will just be a string. Subtype in this case is just going to be like the name, the pound PF, that sort of thing. In this case, I think this is cleaner. So we're also going to need the CPL. So let's take a CPL there. That might be a U16. So we'll do that. And then down here, where we deleted everything, we're going to do classify bad access. And we're going to pass it reference to Franzia, which is already the mutable reference. We're going to pass it a faulting adder. I guess we also need to give it a faulting PC. So we're going to give it Franzia, the faulting PC, the faulting address, an access type, which we're just going to say read for now. We're going to fix this in a second. And then what else? The CPL, which is going to be this. Faulting PC, faulting address. Okay, this is why I split it, so I could kind of look at both. So now we have a subtype. So we're going to say this is a PF. Down here where we do PF, this is going to take another arg. This is now going to be a subtype. Sub under type. So we pass in the subtype, which is a page fault. We pass in the faulting PC. We pass in the faulting address. And I'm just formatting to 80 columns. PC. So this is going to be the faulting PC. Faulting adder. I think people understand that more than linear address. Looks good. And comma this. Good. Faulting PC. Faulting address. Access type. The CS selector, or the CPL. Subtype. PC. Address. Access type. CPL. Okay, that looks good. Let's see if that gives us everything we need. So faulting adder here. No longer need to deref it. Okay, and then here, usually we would want this to print crash type, which is the classified version of it, but instead we're going to leave it as the faulting address just for this temporary test that we're kind of doing. So we're going to get that faulting address, classify bad address. Looks good. So then here we're going to say else if otherwise if the non-canon access is sum, then we can do let NCA is equal to non-canon access dot as ref dot unwrap. We can safely unwrap that because we've validated it. So this is gonna, we'll just say non-canonical access. We're gonna give it the faulting PC, which is simply gonna be self.vm.program counter. Might be it. It might be regs. Yeah, it's regs. It's Franzia, NCA, get the program counter, we get the faulting. This is actually going to be the faulting adder access type. And the current CS is the correct CS to use. Actually, in this case, we don't want to use that. We want to use... Are we not storing the CS? Faulting reg state. Oh, yeah, faulting reg state. Okay, cool. Yep. It's just making sure that that was using the old one. That could have been a bug. So we're going to pass in the access type. And then this, we're going to do franzia.regs. And we're going to have to probably pull these fields out due to lifetimes. So franzia.regs.cs.selector and ox3. I might have a .cpl field on there, actually. See if this builds. Yup, doesn't like it at 311. Probably just have some stuff wrong here, paren in the wrong spot. Okay. This command prompt was kind of broken. Alright, we got a lot of issues. Nice. It's good. It's good. We've got the isWrite stuff in here. So CPL, we pass that in. CPL is 0 to string, otherwise CPL. Get the crash type. If access, we're just going to do this. Match access type, write, read, write exec. Oops. Read, write, come on. Exec, come on. Read, write, exec. This will be crash type plus equals this string. So read in lowercase. Read, write, exec. If the faulting address is not equal to the sign extended, let's take a look at where we do that. We do that here. So this is sign extending at the 48th bit. So if the faulting address is not equal to the sign extended one, then it's a non-canonical access. That's interesting. I must have added like support and then I never actually implemented it because it would be impossible to ever hit this position in the code. So if the faulting address is not equal to sign extended as use size, classified as non-canon, in caps, that's correct. Otherwise, all of those. Then in this case, subtype, CPL, which has been converted to a string CPL. Shared memory, we gonna clean this up a bit. This makes more sense. Okay, that looks a lot better. So we're gonna go into shared memory in Franzia. We're gonna format the faulting PC into a module and offset to put into there, and then the faulting address we're going to directly write out right now, but typically that would write out the faulting type, which is one of those fields. Okay. Crash file, so this also just needs to return I'm gonna put these here. Okay, so this is now going to return this as the string. What else did we do wrong here? Handle crash. Takes 5 but 4 supplied. That'd be anywhere that invokes it. In this case, none. none. Then in non-canon access, we're going to call handle crash. So this is going to take Franzia, the vector, which we don't have. We'll just set that to delete. An error, which doesn't exist. BSOD, which doesn't exist. And then a non-canonical access. So that should correctly go up to the handle crash routine. That's going to go through. If the non-canonical access is set, then we're going to get the faulting address and access type. Both of those are copyable, so we can actually do this. Then we're going to pass in the faulting address and the access type, the program counter. So we're going to say it's an NCA. We'll get the current CPL from that. Okay. So everywhere that calls handle crash except for that one needs to take 5 instead of 4. So this one does. This one does. This one does. That's the good one. Okay. 278, no exec and access type. Yep, so we got to do that before we forget. Oh, it's execute. Okay, so we did do that. Nice. Good done. Good job, past me. 302, faulting PC. Expected reference found usize. That? You really want a reference? Oh, it wanted its tuple. Format mod off. What? Format mod off expects that? Mod off. Okay, so we're gonna have to query the module, I guess. And then instead of faulting PC, I'm doing mod off. No, mod off will also be included. Well, I can do this internal. As long as it's on faulting. No, I can't. This has to be passed in from outside because page faults can happen in a different context. So we will have to pass in the mod off. Yeah, format mod off, mod off. And then to get mod off, we're gonna grab that from. I don't like how that's hacked in there. I'm gonna move that up. So get that, we're gonna map the internal one. I guess we're just changing the format of the mod off. Query module. That. So what is the type? It is expecting this. So we're gonna also need to pass in this mod off here. Kind of sucks, but now everywhere that we do classified bad access, we're gonna need to get access to the module and offset. So in the case of this, this is unwrap the faulting address access type. This is look up the current module offset. Not quite. And then we're gonna pass that in as the final argument. NCA, program counter, faulting address, access type. And that information, that's all passed up through here. And let's make sure that we plumb that correctly. Non-canon access. That looks, we actually don't do this correctly. This is why we double check our work. We're passing up the linear address and the access type. Reg's not found on crash handler. Yes. That is at 352. Oops. This is franzia.regs. We're gonna probably have lifetime issues once we get this all set up. Bad access. And in the case of a page fault, how were we doing that before? How were we doing that before? I don't think we have the information required to do that. So previously, we were grabbing format mod off of faulting PC. But faulting PC, oh, faulting PC is a mod off. I see. Faulting PC in this case is already the module offset. I was like, holy shit, that makes no sense. That means this needs to be we don't need faulting PC anymore. Classify bad access. Faulting PC, what happens if we get rid of that? Nothing. Yeah, we don't use it. Okay. Now we can go to all the uses of this. That just passes faulting PC. And then this one will pass in the mod off, and we can get rid of the program counter argument. Okay, and we just have to deref those. 367. 369. Yup. Okay. Okay. This is going to be let crash file is equal to this. I think that's what they're all doing, right? Yeah. Crash file. Why is that I count? I see, that makes sense. So I count reg state crash file need to always be set. Yep. So this one has a special I count, so we don't have to do it. And then these ones just use the current instruction count. And that's because faults can happen in the past. So we actually have like a stack. It's a lot more complex for page faults. So here we have non-canonical access. We set up the reg state, the I count, and we classify it. Okay, and now 366. This is unused, of course. So we're gonna do let access type is equal to match. Actually, let mute access type is equal to. We're gonna go down. Convert this information to an access type. We're going to say let access type is going to be equal to if not is right, if is exec, then it's going to be an exec. Else if is right, else read. Okay. Okay. Let's set up these keyframes. Re-keyframe it. Set that to false. That means we can now deploy. And now we'll see if we get NCAs. Yep. We'll remove the old coverage. Get this running. Connect up. All the workers online. Okay. So let's think it through kind of what happens now. So those canonical failures happen. So if a canon failure occurs, we go up to here. We get the linear address of the argument. We convert this, the second argument, the access type, into a 012 read, write, execute. Then we invoke all the non-canon accesses with the linear address and the access type that happened. Okay, so that means nothing can happen unless someone registers a callback. This has registered a callback. We're going to get the linear address and the access type, and we're going to pass these to handle crash. We're going to pass leap for a vector and then none none. And then we're going to pass in the linear access and the access type, the linear address and the access type to here, which if this condition, if it's sum, then we're going to treat it as a non-canon access, get the faulting address and the access type, query the module for the current program counter, convert the formatting of the module offset, classify that as a non-canonical access, with this as the faulting address, this is the access type, which were passed up, and then this is the current CPL and the module offset of where we're executing. We'll get the registers and the instructions executed from the current instruction count, which should be good. Okay. Then here in the page fault situation, we're going to see if it's exec, it's execute, write, otherwise read, check if it's PF, get the faulting address, get the access type, which has been converted, pass in the faultings CS selector and the faulting PC, and we're done. So that should be everything. And after all of that, that means we should now start seeing things in here that might get classified as like NCA crashes. They're relatively rare, so it might take like 2 or 3 minutes for one to show up for the first time. But then we'll hopefully, for the first time, see what address was used in a non-canonical access, which is really cool. I've actually never had this capability on any tool I've written. Well, except for vectorized emulation, which can handle all of these, doesn't actually emulate exceptions. But all the hypervisors and emulators that I've used, I've never actually had a tool or a way to get the non-canonical address out. I'm really fucking excited for this. So we also have done no tests along the way. So if it does not work, it's going to be really hard to tell at what part in the process the issue occurred. So I guess we can just sort these by time. It'd show up at the top. Let's make sure workers are running. I mean, they actually might be panicking. Nope. Looks like they're running. All 64 are online. It just means we haven't hit a non-canonical access yet. But yeah, I'm pretty comfortable with this. I think we got it first try. I don't know. I don't see any places that could have mistakes. We built box. We re-keyframed. So basically, we should just delete all the crashes. I just want to make sure that if we get, if we ever see a GP and we don't see an accompanying NCA file, then that means we likely either didn't rebuild our keyframe, or for some reason that information is not coming up at all from box. So this access is kind of interesting here. But yeah, this is something I commonly do. So when I'm actually fuzzing and I'm trying to find bugs, like I'm trying to find everything that I can, I will typically go through and have them classified where they're filtered down, such that you don't have so the addresses get collapsed into kind of those 4 buckets we were talking about. But when I'm actually going to write an exploit, I usually turn that functionality off so I can get full knowledge of all the different ways things can crash. So, like, at this point, if we saw a non-canonical access show up that was accessing 4141414, we're going to start writing an exploit, like, right away. Like, right away, we're going to start working on an exploit. But if we don't see those values, while there might be some weird accesses, they might be type confusions. Like, we have a type confusion here, and that type confusion might be really hard to land. So, basically, we're going to probably let this run out. We're going to let this show us kind of if any really weird accesses can occur. We're just waiting for the non-canonicals. We might need to prioritize those. So what we could do is we could take an existing input that's known to cause a non-canonical crash, and then we can do that, like, always use that as the seed input and make sure that we never deviate it from it too much. So we could basically swap in a mutator that only puts in allocations, and then a generator which only generates the known crashing input. And then that would allow us to kind of randomly add heap allocations throughout something that's known to cause that non-canonical crash. So that's probably going to be our next step. We're just going to try and fuzz a specific non-canonical access to try to determine where we can actually mutate in there, or if we can get control at all. I think for some of these, it's going to be really difficult to do work on that, like, paste on that groom, kind of on a real system, because there's just so much noise. So if we can do the development of an exploit inside of here, obviously it would only work on one case. But the thing is, on a host system, if I'm trying to write an exploit, it might crash in a different way every time. And that's eventually, you want your exploit, you only want to work if you want your exploit to work in almost any heap state. But what we're trying to do right now, we want to write an exploit in a deterministic heap state. So we want to see if there's any way that we can get 4 ones getting derefed. And this could be a 1 in a million chance of happening, like on a real calc.exe. There's no way it would ever happen, but it would prove that it's possible. And then it would give us kind of a jumping off point to start learning kind of how it works, or like the different ways that it can crash. And I don't know, it's kind of cheating, but it's not really cheating. Like, if we were to get something, if we were to fuzz specifically a non-canonical access, and then we were to see that we got 4 ones control, we would probably be able to find a way that we could do keyboard accesses in calculator in a certain way to reset it to the right state, and then to do more accesses to cause the crash to occur in that state. So while in a fuzz case, it might be leveraging the existing heap state in the way it crashes, we can probably coerce that. So I would rather figure out, is it possible to get an arbitrary pointer deref prior to trying to actually write a full exploit. It allows us to have a middle step between basically fully working exploit and this middle ground of or like having nothing at all, I guess. So here we have an NCA. Looks like it came through nice. Let's make sure everything looks sane in the register file. We should see that that is the address being derefed. In this case, that's saying it's RCX plus 8. We, in fact, do know that this is accessing RCX plus 8. This is one we've seen before. But let's run this through just to double check. So, and we should also see... Okay, yeah, we're not seeing the general protection fault here because we're resetting the VM immediately once we see this NCA. So it's never making it to the GP fault. Okay, so now we can take this. We can run it locally. Cargo run start. Cargo run repro. Calc stepped. We might have this in our history. I can't remember which window we had the repros in. Here we go. And now, boom. And this will connect in, and we'll see what our repro looks like. Oh, yep, we need to make a copy of that. Calc stepped. What do we want? Calc stepped here. Paste. Okay. Good, and oops. Okay, we're connected in. This should give us the repro. We'll get to see what state it's in. It should match what we're seeing, where it's faulting at that that module and offset. Okay, there we go. If we do a db on rip minus calc.exe, this will give us kind of the offset. Reload. Okay, so this is giving us the offset into that. It is 2AC01, looks good. If we look at the faulting address, it's going to be this address. Everything lines up. So it looks like we just kind of got everything right first try. That's what I like to see. All right. So now we have a fault in this situation. Twitch drops the quality automatically if the browser is in a different tab. Yep. Yeah, it's kind of annoying. So I think if you turn it off auto, maybe, if you put it on like the source quality, but I'm not 100% sure. But yeah, it's annoying because you like tab over and it's blurry for like a few seconds. So anyways, that's the crash. What we're going to do is we're going to wait just a little bit. We want a little bit more crashes to come in, and then we're going to create a corpus, and the corpus is going to be fixed to a very tight set of inputs. And that's going to make sure that we don't end up potentially... we want to drill into these. So we want to like put a really heavy focus on this to make sure that our groom attempts are kind of hitting these enough. So in fact, what I'm actually going to do is I'm going to take the server offline. And what I'm going to do is I'm going to disable the mod 4, the mutation of flip up to 4 commands. I'm going to just move this out. This is going to be a different mode. If drilling, then we're going to do this. And we're going to return. So during drill mode, only insert grooms. And then here, we're going to select a random location, and we're actually going to do input.insert. This way we don't modify where things are. Actually, we want to do a mix. So 4 and 0.10. So we want to insert 10. Throughout our input, we want to insert 10 random grooms. So we will do this. Input cell is equal to command. So this is basically going to turn off coverage, right? Oops, bool equals false. So whether or not we're trying to find grooms in a specific set of inputs. We're going to call this grooming. And this is going to be a different mutation strategy that's going to be more heavily focused towards taking an existing known crash and creating new crashes out of it. So that's good. And this should just take immediate effect. We don't have to really change anything. And effectively, we're no longer doing the groom in the standard mutation loop, so we'll never try and groom when we're actually fuzzing. So we'll focus on fuzzing, and then when we're grooming, we're gonna focus in like a completely different mode. So pick that, fill it into a random location, send it off. So now it's kind of just a matter of waiting for interesting crashes. So it starts off by like syncing kind of these things. What I could do is, I don't know, we could just try and start drilling into this right away. Let's see what happens. We're gonna take an NCA, and we're gonna try and see what happens. So we're gonna put this into the grooming mode. We put that in the corpus. We're gonna get rid of all inputs. We're gonna get rid of the coverage file. So we're gonna start a new case, or a new fuzz test. It's going to give this crash. It's going to supply that crash into here, and then basically, I think we want to never use the generate routine. Because the generate, I guess I want to like hot path the generate, so get input. In TKO, I think we have like get inputs, get random input from the shared memory database. This is implemented on Franzia, I think. Yep. So what we can do here is if grooming input.clear, we'll move this up. If we're grooming, then we're going to clear the input, and then we're going to replace the input with input.extend from slice franzia.getInput, which will get a random input. I think that's an option. It can potentially fail, so we're just going to say we know that in grooming mode we're always providing something, so it shouldn't be able to fail. We actually want this, so expect grooming could not get existing input. Do you have a seed corpus set up in the corpus folder? Okay, grooming could not get existing input. So when it's going to generate, if we're in this grooming mode, trying to find variants by mutation of our corpus, which has been manually selected for analysis. Okay, grooming, extend from slice, get input. Good. Down here, grooming. This is going to just do all that sort of stuff. We're gonna go, we're gonna set this up at the top. Okay, grooming. So we're only using existing inputs, we don't generate new ones. And then in this case, we're going to, and then in this case, we're going to get the inputs into chunks. Then we're going to do that. Otherwise, we're gonna do this. And the reason we have to do this is we have to reserialize it out. And we just need to make sure that we have that path clear. cmd.2bytes. Known commands. For cmd and input, input is generated here. If we're grooming, we do these. Otherwise, we do all this stuff, and then we reserialize the commands out. So this should start, yep, loaded one file from the corpus folder. So we have one file in the corpus. We should have no inputs, no crashes yet. And now we're going to very frequently see that crash. That crash should show up right away. So we'll see a lot of these crashes, and hopefully we'll see a couple variants based on that groom. We might need to add like some splicing in there to fill it in. We could potentially use the actual mutation strategy on it, and that might be fine to like insert and move things around. So we're just gonna play around with this, and we're gonna see if we can get 4 1s magically, and if we can, then we're gonna focus on how that's possible. So. And basically, the reason we're trying to do this kind of in this automated fashion, I don't know why these aren't online yet. So the reason, there we go, page fault 8. I think I need a chance of very little corruption. NCA, there we go. So they reproed. Those are probably cases where it hit things that weren't involved. We got a couple more in. So now we can classify these bugs, and we can say all of these bugs are likely related. These are probably all the different ways that this specific bug can crash. And I think what I need to do is I need to make one more change here. I want the, I want it to be up to 10. So there's a chance of doing no corruptions and a chance of doing very few corruptions. And we're gonna actually do, we'll go up to like 24. And then here we're gonna say up to 300 is probably good. We're gonna go up to 400 just to increase the search window on grooming. Here that loaded some inputs, so we want to delete those existing inputs. Okay, we loaded one file, and we're going through and we're feeding that through as much as we can. We might want to add some mutation to that. Hard to say. Just waiting for those first crashes to come in. And then we're going to probably want to start doing some splicing, and we might want to put this in fuzzing mode, but where it's always based on the same input. So it's only ever mutating this this like screwed up input. This is a situation where it's going to be a little annoying that TKO automatically provides an input and doesn't always call generate. But let's see. There we go. They're starting to come in. Okay, we're doing pastes, which is good. So we're using the same base input. So the question will be, can we get a non-canonical address that is much different than this one based on adding these random pastes throughout the application? So I would expect that if we can affect it with the mutation strategy we have now without adding or inserting or padding these exceptions in here, or the grooms in there. But hey, you never know. You never know. So if this doesn't work of like trying to find an input that does crash in 4-1s, this is kind of an initial pass I use. What's nice about this is you can automate this and you can scale this out. Even if it's not as good as a human going through, you know, if we spent all of today just looking at this one crash and trying to figure out how to reproduce it, or like specifically what the bug is, we could write a groom specifically for it. We wouldn't be randomly guessing heap bins. We would know exactly what heap bin it belongs to. So we could potentially log all of the allocations in a repro, and we could see the size of the allocation that it's going out of bounds of, or okay, so that one, interesting. So all of these crashes are related, which is pretty crazy. So like all the null derefs are clearly related because the only thing we're doing is like removing. I guess that's not true. We might be removing the things that are causing the non-canonical to happen. Come on. Okay, some more came in. Problem is now we're basing things off of inputs that suck. Yeah, we need to, I think what we need to do is let's go into the generate callback. If that self-persist feedback rate. That over 2. If it's set to max, every fuzz case should be sourced from the input data. Otherwise, God, I'm so glad I fucking add stuff like this. How nice. So this is gonna tell us the frequency that we call generate. Every fuzz input will be sourced from the input database. If it's 0, then a new input is almost always generated. There's a 1 in max chance of rolling a 0. So we'll set the feedback rate to, in our fuzzer, we'll set our feedback rate to 0. And that will cause Franzia. This is actually in persist, so we're going to need to make an accessor for it. Pub fn set feedback rate mute self feedback rate. Did I do a U32? Something like that. Self.persist.set feedback rate is equal to feedback rate. Okay. Feedback rate is just that. Might not have done a U32. 1261. Found U size. Yep. Okay, and then feedback rate is going to be used. I need a good way of like referencing that comment down here. I don't know. Gets the rate of feedback for the fuzzer. Sets the rate of feedback for the fuzzer on a scale of 0. No input feedback to U size max. Always input feedback. Okay, so that exists now. So if we check where feedback rate is used, it's gonna roll a random number. If it's less than that, oh, 0 isn't less than that. If it's 0, then it's almost always generated. That's not true. That's not true. If this is set to 0, this is always going to be true. It's the opposite, I think. Yeah, it's the opposite. If it's set to max, well, we can make that true by just doing this. And we can make this correct too. We can say if that, or this is greater than 0 and this. So what does this mean? If this is set to max, this is always true and this is always true. If this is set to 0, then this is always false. Yep. Am I wrong? Oh, sorry. I didn't know if that no was for this. Is always generated. Will be sourced from the input database. If it's 0, a new input's always generated. Let's double check our work. So the only way that we can generate is... Oh, whoa. It was wrong, yeah. So we want it to be 0 is always generating. So if it's 0, so if it is equal to 0, or, so if it's equal to 0, then we're always going to generate. Otherwise, unless we don't need the parens. So if we don't have an existing input, or the feedback rate has been set to 0, or a random number that we generate is less than the feedback rate. If feedback rate is set to true, or if, actually, fuck. I think I have this logic wrong. If the feedback rate is 0, always generate. Otherwise, if the random number is less than the feedback rate, then we also generate. I think we want greater than here. And that would mean that, because we just use an elf. Where do we go? So the else case is where we use an existing input. And so the else case can only happen if this is sum, or if this is sum and feedback rate is not equal to 0, and the feedback rate, so if this is max and this is always false, which means this would be impossible unless these, and that implies this. And okay, so this should be good. This is now what we want. Self.rand is greater than feedback rate. If the feedback rate is 1, then the odds that it's greater than that are very high. Oh, we do want less than. Why am I struggling to reason about this? I feel like I'm not implementing this as feedback rate, and I keep confusing myself here. Okay. Let's see. Feedback rate. Natural with number is less than or equal to it. Indicates input blah blah. Yeah. Feedback rate is 0, or that. If rand is less than the feedback rate, if that's a high number, it's always going to happen. Is that right? Or that? No, I think I do have it backwards. Keep getting it wrong. Hey, Raph. Thank you for following. What's up? I feel like... Why am I struggling with this? If a random number is greater than the feedback rate, then we generate. If feedback rate is set to max, feedback rate is set to max, that would mean the self.rand would almost never be greater than that. This would also be false, and this would be false. Okay, this is definitely correct. And then there's no way that it can ever be greater than max int, which means this will not happen. Okay. Whew. That was kind of twisting my brain there. I don't know. I get hung up on stupid shit like that all the time. Okay, so now in here we can set the where can we actually do this? Can't do it in a init. Well, I guess it will start off here, so we can do if grooming. We'll do franzia dot set feedback rate to 0. That will mean that this is equal to 0, which will always go into the generator. So this will always get invoked. What we can do is we can now provide one of these inputs kind of directly, like in memory. So we could do that here. So we gotta grab this. We gotta do like the Linux Windows stuff again. It's kind of annoying, but whatever. We can make it work. CFG Linux, CFG Windows. So this will be the I don't know. Maybe I can just set it so I might want a different mode here. Might have implemented all that for naught. I think what I want is I want inputs to not be added. I need a way to filter automatic input adding. I basically don't want okay. So if we look for add input, and then add input is here, and I could just say, oh, that's on shared mem. I'm gonna have this in franzia. I basically want a way to make it so it doesn't save inputs automatically in any situation. And I'm struggling to think of a really clean way to implement that. I mean, I could add like if statements on all of these, but that's not particularly what I want. This. If it doesn't add any inputs, it'll always just mutate the existing one. But I want to have a set. So basically, I want a way for the set of inputs to not get polluted. Here's what I'm going to do. We're going to add a corpus, brawler.getCorpus. Corpuses will get added to the input set. But then we're also going to want to add those to maybe a corpus set, or especially tag them in some way. So let's take a look at shared memory. So problem is input adding is pretty complex. Add input, hash table entry. This is gonna do the internal stuff. Right, creates the input. I guess it's just an alloc and a copy, right? That adds it to a hash table. We don't care about a hash table. We can just do shared mem. Okay, shared mem. Inputs, pointer to inputs. Where's that input len? Num inputs. Here. Here we're gonna do corpus. Buffer size in bytes. Number of corpus entries. Corpus. Okay. So pointer to the corpus. Then we're gonna have man, the viewer counts are like jumping all over the place. I don't know if my stream's like cutting out or what. Keeps tripping me up. Shared memory. Gonna go in here. Num inputs. Here we're gonna do. Get this as the shared corpus. Num corpus. Num corpus. Okay. Yeah, Twitch is just doing weird stuff. Get input. Okay. How do I want to implement this? I need to do this better. I can do this better. Num corpus. So inputs. This is going to be a set which is based on struct input type crash corpus feedback 0 1 2 input. We can get rid of these. Input was generated due to a crash. Input was part of an initial manually controlled corpus. Input was saved due to generating new coverage. Input type coverage. Cool. Wrappers see that bitch. And then we're gonna do derive clone copy partial EQ partial ord hash debug different types of inputs in the input database. Okay. If you add an input type here, make sure you increase the max input type constant. const max input type. So usize input type coverage as usize plus 1. Maximum valid input type. I don't think Rust has a way of doing that. This should be an enum as well. We'll actually repr usize this. Why not? Makes more sense. So, that takes up more storage space though. Whatever, fuck it. The input type 012, crash corpus coverage. Then we got a max input type, which is a constant from input type coverage plus 1. So, or this is the num input types. Actually, we'll do the max input type and we'll just give it this. We'll do the plus 1 somewhere else. Make sure you change max input type, the max input type constant. Okay, now we'll go to input. Fuck, this is gonna get really hard. This is some of the hardest code to work with in the code base. Tuple is that. Pointer to inputs for each different input type. This is then num inputs is going to be based on the input type. So atomic usize, an array up to max input type. We're gonna have inputs here. Shit. So this is gonna be like this. Pointer to all inputs. All inputs. Num inputs is gonna be this. So basically we're gonna have the, what's in my clipboard? I feel like something's in my clipboard and it's important. Max input type, kind of. We got an input hash table. So basically we have an input hash table containing all unique inputs. The hash table contains the index in the inputs table, and this is allows deduplication of inputs which have the same contents. And then this is keyed by a hash of the file contents, and then it points to the index in this. This is currently how it works. I think this should build 538. We just added a function that doesn't exist. So this makes sense. Everything will go into the input database, but not everything will come out, I guess. So corpus is never used, num corpus. Of course, we're not using these fields. We're gonna call this inputs and indexes to the corresponding entry in the inputs array. Corresponding to the inputs array. This is going to be inputs categorized by input creation reason. And then this is going to be input reasons. The reason all of these are atomics is because this is shared. So we're working in a shared environment, so we have to think about how this is going to work for all possible inputs. So we're going to do this. Tuple is, we don't need a pointer, we just need an index. Tuple is, this is kind of tough because I need a way to wrap this in an option. Because 0 is a valid index. What's up, Nanda? How's it going? So a tuple is, in this case, there's no tuple. Entries point to the index in the inputs table. Okay. And then this will have an outside array. I mean, we can just pair this with the number of allocated things in it, and then this is the max. What do we call it? Max input type? Yeah. Okay, so we've got an array of max input types, so we're going to categorize by those. Then we're going to have a vector. For each input type, we're going to have a usize, which is the number of elements used in this array, and then the atomic usize. And we need to initialize this to probably all Fs for these fields to indicate that they're invalid entries. So we'll say invalid entries in this list will contain not 0. Okay, and we're gonna need to go initialize those in a different location because those are gonna get default values. So an input will come in, it'll be selected by its input type, it will then get the size of this database, and then it'll update the field, and fields can temporarily, as long as this is insertion only, this should be thread safe. So I think everything we're doing here is kosher. And we're gonna call this typed inputs. By their categorized by input type. Okay, sweet. Now none of this is hooked up, so we're gonna have to start hooking this stuff up. We're gonna open. We need to vertical split this pretty bad. So we're gonna go to inputs and typed inputs. Okay. Num inputs is going to get that. So we're going to have add input by hash entry. This is done there. This is done here. These are going to take types. Maybe. These need types if and only if. Yeah, these need types. So this is going to take input type, which is input type. We're going to pass that through, and this one also will take an input type. Excuse me. Okay, that takes the hash, the input. So we now have this. This can simply call this. Okay. Sweet. Now we have to fix everywhere that doesn't work. Add inputs. So, okay. Add input this. So this needs an input type. Corpus. Because that's coming from reading this corpus directory and all the files in it. This one is coming from coverage. New coverage occurrence. So this one will get tagged with input type coverage. Okay. And we've got a couple more. This one is done due to initial corpus loading from the server. So this is going to be input type coverage. And we've got one more, 2213 special case. This one is going to be syncing inputs that we don't have based on coverage. So this is going to be input type coverage because that's coming externally from the server. So this is basically when we load a keyframe, we sync with the server to get the coverage information from the server. 410, this is public. Okay, crash handler is going to fail because crash handler calls this. So, and add input. Here it's going to take input type crash. Nice. Input type. Beautiful. Okay. So now add input. Add input is just a wrapper function on this, I think. Add input by hash entry. Yeah, if we're ever adding an input, it will end up going through this function. So we don't have to worry about any other cases except for here. Here we're going to add this input to the input database. All done, we can fill that in. That's going to give the input ID and the hash, which we do nothing more with. We just return that out. Returns the index of the input and the hash. Okay. And then here, we now are going to insert it in the other database. So we're going to take a look at typed inputs now. So now add the input to the corresponding typed input database. And here, what are we gonna do? We're gonna go nap in a bit. Didn't sleep very well. Yeah, get some good sleep. Thanks for joining us. Add the input to the corresponding typed database. So here we can get access to self.typed inputs. Input type as usize. Input. So this has now gotten inputs for type. So this now has a reference to those things. Corpus is never used. Okay. Inputs for type. I've got typed inputs here. Let's see. Inputs for typed. Self-typed inputs. And now what we want to do is let input ID. At this point, we know that we have a unique input, so we can insert it into the database. We don't have to check if it already exists in the list because it can't exist in a coverage list because it doesn't exist in the global list. Now, is this going to cause us to not categorize input? This will only categorize inputs by the first type that they hit. This is kind of acceptable for now, but it can be confusing. Typed input ID is going to be equal to inputs for type dot fetch add 1. We're going to get a unique identifier for an input to use. We're going to do ordering sequentially consistent. And then we can do inputs for type at offset typed input ID, because that's a unique ID. We can now do store of the input ID ordering sequentially consistent. Yeah, so this is .1 and this is .0. So this is the count and this is the length or the database. Okay, everything's good. So now that should be classifying inputs based on their type. So it will be putting them in this different list. It will be tracking basically inputs that go through there. So next I want to get input. So this is get a random input. fn get input. So we're going to have 1. This is going to get it from shared memory. This is going to get the input ID. This is the function that we're going to build on top of. That's get a random one from the database. And in this case, get access to shared memory. If it's equal to 0, return none. Otherwise, get input of this. And get input should spin. Maybe we should make this spin. Get input, blah, blah, blah. Make sure that that is in bounds. Then we're going to get a reference to that. We're going to load the pointer and the length. If the pointer is not null, I think we want to spin here. I think that's what I'm going to switch to. So if the pointer is not null, the pointer ordering actually matters in that case because we have a length associated with that pointer. Let's see. When we go to add an input, do we update the pointer last? I bet we make a comment for that. Yeah, ordering matters here. The pointer must be the last thing that gets stored. Yep. Okay, so here, if that input database has been exceeded, so we get the num inputs, we're going to get a reference to the input ID. We're going to do while the pointer.load ordering sequentially consistent is null. We're going to do this. So look up this input in the database, spin until this input is active. And then we're going to put another assertion in here. Assert that input ID is less than num inputs. Attempted to access an input that does not exist. This should just never happen, so an assert is fine here. We don't need a warning. We can now make get input non-failable. So make sure the input, make sure that someone has reserved room for this input. This will make sure that the input will be filled in soon, and thus the spin is going to be quick. We're going to look up the input in the database. We're going to spin until this input was filled in. It'll start off as null. It will, once this becomes non-null, this is good forever. Then we're going to get the pointer and the length, and then we're going to grab that input. So load the pointer and length and return a slice to it. Okay. So 1551. Get input. This now has to return a sum here. Basically, if num inputs is 0, we return none. Otherwise, this will definitely be a valid input, and thus it will spin, and that will be fine. So now that's not fallible. This is also not fallible. Beautiful. Okay, now we're going to implement kind of the same thing. Typed inputs. Oops. Dot default. Here. Actually, where we create shared mem. Column shared memory is allocated. Shared mem. I think this is only cast to. Get access to shared memory. Who creates this? This would be done. I think everything in here has to be safe if zeroed. If we look at source lib, shared, create shared mem. Create shared mem, I think, is just going to. Okay, it will set things up in here. So here, what we're going to do is we're going to go through everything in the input in this typed inputs table, for in 0 dot dot max input type dot dot equals that, and this will be max input type plus 1. So for every possible input type for each input in shared mem dot typed inputs, I don't know, I feel like I should just put this in a fucking init routine. Make much more sense. Pub fn initialize self initializes the state of shared memory to a correct state. This should only be done once when a new shared memory file is created. Okay. Invoke shared memory callbacks. Don't have access to those. Here. Boom. Tab this in. Self. I need to pass some of that stuff in, I think. This. Yeah, I know I could find and replace, but I want to actually like pay attention to what I'm replacing here. For input in this, we're going to do an input dot 0 dot store this ordering mark all typed inputs as invalid. Okay, and then we have a lot of these settings, which we now are going to grab from source settings. Oops. Well, SP source settings. Okay, all these database sizes are going to go up to here. Ah, got something in my eye. Okay. Then we have all those. Looks good. Backing is pointer. Set shared memory backing. Here we're gonna do shared mem.init. Initialize self. I think this is good. Shared mem initialize self, and then this will take backing. So this is the raw backing of self, and and this is just going to be a slice of U8s, and that allows us to compute lengths and current allocation states. We're going to put these as backing. Backing should be the slice of U8s that was actually allocated to create the shared memory. We use this to determine the over allocation size to create our shared memory allocator. So we have to use a custom allocator for this, since we're doing some like really weird memory sharing stuff. So this basically gets access to all of those things. Shared memory not found in this scope 597. Self set coverage event time 592. For this in typed inputs.iter, typed inputs input type.iter, and I'm gonna do a reference instead of an iter. So we're gonna go through each possible input type. We're gonna look that up in this list. I mean, we could just do a double iterator for input for typed inputs in self.typed inputs for input in typed inputs. So we iterate through the outside, and then we iterate on the inside, and we fill everything in with a not 0. 592. It doesn't need to be a ref. Okay. What do you mean that's not an iterator? For typed in for inputs, num inputs, which is not used, go through inputs. There we go. And we need an and. Okay. Really? Into iter is not implemented for that? Okay. Iter is. No field 0 found on atomic use sizes. Yep. So we're just filling all those in. Okay. 64 is our backing. It's complaining here. Found a mapping. Borrow. Nice. Input dB size. Yeah, all these dB sizes are gone. Okay. Nice. Atomic use size no longer used. It's kind of nice. Whoa. AHT no longer used. That means I can drop rid of the dependency on HT in here. Cargo toml. HT. Okay. Nice. Looks good. So now we've categorized these things. Add input. Add input takes an input type. We add that to the input, the typed inputs thing, and all we do is we get a new input ID, and then we fill in at that input ID. We fill in the input ID, and this input set is all Fs by default. So now what we can do is we can get a typed input. So pub fn get typed input gets an input from a specific input type. It's going to take in a self type input type input type input ID. So this is going to be the typed input ID. And what this is going to do is we're going to do a while self dot. So we'll do let input is equal to. So we're going to get a reference to the self dot typed inputs. Input type as usize. Typed input ID. While input dot load ordering sequentially consistent is equal to not 0. While the entry is invalid, spin. Grab or get an input from the database. Has the mainframe been breached correctly? Oh yeah, we breached that mainframe real good. So get an input from the database. So use the input type to select the outside, then get this one. Then while the input.load is equal to not 0, we spin, and then we just return by doing a self.get input. Input.load ordering sequentially consistent. Now fetch the corresponding input. That's really clean. It's all safe. 742. I say it's all safe, and then we're gonna like actually hit crashes. Cannot index a value of that. That makes sense. We want the database. Actually, we want typed inputs. Get access to the typed input information. We're gonna grab this. We're gonna assert typed input ID is less than self.typed inputs. It's still safe, but we're gonna make this so we can assert in a prettier way. So if this is less than typed inputs dot one dot load ordering sequentially consistent, attempted to access an invalid typed input ID. So we make sure that that is within bounds of the number of inputs. And then here, we're gonna spin. Okay, and this will be let input is gonna be equal to self dot input. This is equal to typed inputs dot 0 typed input ID. Get access to the specific input, and then spin on it while it's equal to 0, and then finally return it out. And then this returns U8. Okay. And now we're gonna do a pub fn num typed inputs self input type input type usize get the number of inputs of a specific type from the database. This is going to do self.typed inputs put type as usize typed inputs. Then we're going to get the .1 .load ordering sequentially consistent. So that will get the number of typed inputs for a specific input type. Okay, and now what we can do is get input below. We can now do get typed input, get a random typed input from the shared input database from the shared typed in, it's redundant, but this is going to be a input type of input type. Going to get access to shared memory. Here we're going to do if shared mem dot what do we call it? We want shared num in typed inputs. So this we're gonna do get the number of inputs is equal to this for input type. If the number of inputs is equal to 0, return none. Otherwise, we're going to get typed input for input type and then a random number from 0 to the number of inputs, non-inclusive. And then we're going to do none in that case. That looks good. So now we have a way of getting an input from there. And then in our generate routine, in our plugin, calc fuzz, now we're going to be able to set the coverage feedback rate. Set feedback rate. So here we're going to do franzia.set feedback rate to 0. And we're just going to double check. This should make sure that basically we always generate. So if feedback rate is 0, and since this is an OR, this will always happen. So we'll always call generate, which means we'll always go into the generator. Then in this case, we're going to do get typed input input type corpus. Use libtko input type. So now we have a way of always getting an input from specifically the input corpus, and that means we won't be selecting from the feedback. So now we'll make sure that we're always starting. The starting file that we use is always something from our corpus. And the way we implemented everything is shared between memory of a single computer, and it's also shared remotely via a remote computer, or via the server. So input type corpus. We're actually gonna need to plumb up the input type to the server if we want to send them back down with the same typed information, and that we can implement pretty quickly. But so this now is going to only use the inputs in the corpus as the basis for fuzzing. Where's that? Delete. Yep. This. So we've got one thing from the corpus folder. This is going to always try to get a random input from the corpus, and in this case, there's only one input in the corpus, so it's always going to be the same file. So, looks good. We'll see what happens. And then that's going to allow us to, and then we return out. So, yep. Basically, if we're in the grooming mode, we're always going to start with an input from the corpus. And then we can turn on kind of all mutations again here. We're going to probably look into that. Actually, grooming could not get existing input. Okay. Get typed input from the corpus. Potentially a chance that they haven't been synced. I'm going to see if I can run it local. Cargo run start calc stepped. I think this one will work. Yeah. So this will work, but over the network, I'm gonna modify this to spin up only one thread. And we're gonna connect to the server. We'll spin up the server, and what we should see is that this is gonna fail, and that means we might be tagging the input incorrectly when we download the corpus. Inputs 2. Grooming could not get existing input. How do you get typed input? Okay, I think the issue here is if I only add inputs that are unique, which means that when I push down the corpus thing, it only will end up in the first threads. So that's why it was working on a single thread, but on multiple threads it won't work. So what we need to do is we need to this is really hard. I might need to add another hash table per input type. Shit. Yeah, I feared this. So basically, if we look at where corpus input, where a corpus gets created, if we look through what's happening here, we've got invoke shared memory callbacks. This is when we're loading from the corpus folder. Actually, are we doing this on the server stuff? If we're not in client mode, then we do this. Otherwise, where's the add input corpus in the input type? So everything in here, add input, initial corpus, initial corpus, get corpus, add input. This should be corpus. Does that fix our issues? Should memory add input corpus. So that's going to go into add input. And then add input is going to see if this is in the input hash table. And that's not going to cut it. Yeah, so what we need to do is... Fuck, this sucks. This is really complex. So this is now going to give us input ID, input hash is equal to this. This is going to tell us... So first, we're going to add the input to the input corpus. So when we report a new input, we're going to add it to the input corpus, or the input hash table, which is going to deduplicate it based on the hash of the input itself. So here we hash the input, we get an entry for the table, and we fill that in. Problem is things directly call this. From hash entry. I need to figure out how to get higher code duplication in here. Otherwise, or higher code reuse, because otherwise I'm going to have duplicate copies of the same code. So why do we implemented this for some reason? Let's use down here. And that's so we can look up an input. Yeah. Okay. Okay. Add input by hash entry. Input type. That'll fill it in. This will go in, and we want this to input already in database, return out. Okay, here's what we're gonna do. So if we're adding an input, we're going to also categorize it. So we're going to add it to the correct category. We have the input ID and hash. And then I need to check input hash table. We should use this. Anywhere we use this, we should do add input by hash entry, which is good. That means if we miss the input hash table, it's unique to this anyway, so we're fine. So the only other situation that matters is this. So what we're going to do here is we're going to add to the typed database. So, oops. So we're going to have to add another hash table. We're actually going to have to add multiple hash tables, one per. So here we're going to have the input hash table. This is going to be the typed input hash table containing all input ID. Do we want this? Yeah. If every time we add an input we classify it, is that an issue? No, it's not. I think we might actually be fine. If we add an input and we've never added it before, we add it as this type. We'll only add things as the first type they're seen as. So as long as we send the corpus first, this is fine. I think we're good. I think that bug we fixed should do it. 897. So this is only correct if the corpus gets added first. Yeah, you know what? This is not correct enough for me. So this is the input hash table. Hash table indicating the hashes which are present for each hash table, which is indicating the hashes which are present for each different input type. This is used to make sure that we can have the same input stored in multiple input sources. So this is going to be the typed inputs hash table. This is going to span in an array for max input type. We're going to have to create this hash table. So input db size. We use that here, but not in the other one. Well, that's a mistake. Input db size. We'll want to put this in input db size, 32 times 1024. So inputs, this is set to input db size, and this is also going to use the input db size. That way this can always exist as long as this exists. Then we're going to make the... that was not what I wanted. Yeah, it was. Okay. And then the hash table is going to get created based on that. What's up, Code Dina? How's it going? Typed inputs hash table. Okay, so where we go to create the input hash table, we're going to make a copy of this code, and we're going to put it in typed inputs hash table. So we're going to do for table in self.typed inputs hash table dot iter. So for every table in here, intermutably, we're going to get elk config. We're going to allocate for the typed input database is set the input hash table. We don't need to use that anymore. We don't need these accessors at all anymore, which is actually really nice. We can do self dot typed inputs hash table. It's going to be equal to this. And then we can get the set input. Basically all of these can go away. All these. So we can get rid of some setters, because now we're working on this in the correct file. So here, this will just be input hash table. It's going to be equal to this. Looks good. I think all this shit should be unsafe. Pub unsafe fn. Now we can do this. This. Typed inputs hash table for table. We're going to set the table. We're going to assign this table entry equal to an existing hash table of this. And we need to allocate for... Wait, when did we add a contiguous table? Well, shit. Covered hash table is equal to this. Basically, if we're maintaining a separate list of things in a hash table, which I think we are with the input sets, we no longer need to do that if we have a contiguous table in our hash tables. So I'm going to take a look at that. We might be able to clean up some of that code. Module ordinal table. This task list table is going to be equal to this. Get rid of unsafe blocks. Oops. Page cache table is going to be equal to this. Deleting code feels so fucking good. If you're not deleting code frequently, you're missing out. It means you're probably not improving your code quality. Deleting code is really important when doing any work, in my opinion. Module Logical ordinals. Task list table. Page cache. Task list. This. Okay, intermute doesn't like that due to a borrow on self. Yeah, it doesn't like it. So this is create all the typed input databases. So first we're gonna just allocate them. So we're gonna do let mute typed db elx is equal to vector new. Here we're gonna do for in this dot iter. We're gonna allocate these. And then we're gonna do typed db elx dot push elk config. This will allow us to allocate in a different loop, and then we'll do assignments. So here we're gonna do now we can do an II. We can enumerate this to get the index. We can just barely fit that on one line. Create all the typed databases and then assign all the typed input databases. And then this will be typed db elx ii.0 and .1. That fixed the safety issue there. Okay, so go through, create an entry for all of them, push those to a list. Then we're going to go through and we're going to assign them for their corresponding entries. Looks good. Call to unsafe function. Source lib.rs 61. Very unsafe. Initialize the shared memory. Whoa. I just did a desktop switch. Son of a bitch. Sorry about that. Okay, so that builds now. Everything's good. We should create all those databases. Everything should be happy. Okay, now what we need to do is when we go to add an input by a hash entry, we can vertical split this again. What we want to do when we add an input, so when we add an input for the first time, so add input by hash entry implies that the input does not exist in the database. Thus, we're going to unconditionally in here fill that into the input database. And then that means that this gets filled in here. We don't have to worry about it. And then the case here. Okay, I think this logic is sound. So now we have the typed inputs hash table. We're gonna get in. We're gonna add the input to the corresponding typed input database, but we have to add a hash entry. So we'll do match self.this fetch or insert hash hash. Okay, and then on the OK, we're gonna panic here. Somehow we had a new input but exists in a typed input DB. This should never be possible, so we'll panic on it. I like doing stuff like this. Things like this catch bugs and have zero cost. In the error case, we have an entry here, which needs to be filled in. Basically, this is going to follow kind of the same logic as above here. Actually, we're just going to do self.add typed input, self input type hash u128 index usize. This is going to add a typed input pub fn add typed input self. So this will add a new typed input to the input database. Returns a tuple of the input hash. We don't need that. We'll figure out what calling convention we want to use. This is going to take an input type, input hash. We'll just call it hash, and it's also going to take in an index. Okay. Or in this case, an input ID. So we'll do this. This will take in an input ID, which is a usize. Okay. So we're going to go into the typed inputs hash table for the input type as usize. We're going to go into here. Then, if it does not exist, we're going to allocate a new entry. Okay, hash. If it does exist, well, now this is fine. Now this doesn't panic. So now we want to return a, what do we do for this convention? We return a usize of the typed input ID. We're going to return a usize of the input ID. Well, we already know that if you're a caller. So all this has to do is returns the typed input ID for the new input for the input, or gets the previous typed input identifier for an existing one. Returns the typed input ID for an input. Okay. So in this case, it exists, and we can just grab the dot int, I think. htint. That's the usize. Yep. So here we can grab the htint, and in this case, return old typed input ID for existing inputs. Then in this case, we're going to, what do we want to do here? We're going to get the inputs for a specific type. So allocate a new input ID and insert this input into the typed input database. So we're going to get a typed input here, input for type. Get a new ID. Add this input to the typed input database. Okay. Now that we've done that, we've added it to the input list. Now we just need to fill in this vector, this hash table entry, and that will look like this. It's the exact same code as below. 6, 5. So we're going to allocate a usize. This is going to not be the input ID, but this is going to be the typed input ID. And the typed input ID I think we just want to do this by hash. No, this is good. We're going to allocate one usize. We're going to set the typed input ID to that, and then we're going to write the metadata to the hash table entry to fill it in. Okay. This is going to be an htint. 807 fetch or insert. Doesn't like this on this. Typed inputs hash table, indexed by that. Yep. mismatch types, 812. It's not happy about this because we're not returning the typed input ID. Return out the new typed input ID. Okay, now there should be nothing in the code base that accesses typed inputs anymore except for here. Obviously, we're going to have one that initializes it. This one is going to get the number of typed inputs. This is going to get a typed input by a typed input identifier. But the only places where we add to it will be in here. Now we just need to make this self.add typed input. Looks good. And then here, we're just always going to do this. Input already in database. Make sure it is also tagged with the input type. Self.add typed input, input type, hash, input ID is htint. I'll return out the input hash ID and hash. So in this case, it will get added. Add the input to the database for the first time. So the first time we ever add an input to the database, it will get logged also with an associated type. However, if we're just adding an input but it already exists in the hash table, we also want to update it just in case the type parameter has changed. Add typed input. Expects 3 parameters. Type hash input ID. I don't know. I'm passing self there. Sometimes I don't even read the code that I'm writing. Okay, so we're gonna pull this up. I think this should just work. I think we just did everything and we did it correctly. So basically, inputs, regardless of how many ways that you add them as different types, will always end up in the input database. I guess it's possible if you're directly using this, then it's a new unique input. Otherwise, you're using add input, in which case you're going to here. Okay. I just got here and it looks so complicated. This is one of the more complicated parts of this tool. This basically allows multiple processes to share the exact same input corpuses that are used for a fuzzer at the same time, atomically, without locks. So yes, this code gets really fucking complex. Okay, so that worked. We're gonna spin up all threads again. All right, so now we've modified our plugin, calc.fuzz. We've modified this to set the feedback rate to 0, which will cause it to always generate a new input. And then in the input generator, we will unconditionally get a corpus typed input from the database. Input type, and here I'm just gonna see what we use for types. Max coverage, correct. Here we're gonna add from the corpus, correct. Here we're gonna add it as coverage because there's a coverage event. Here we're gonna add as a corpus event because it's a corpus event. Where are we at? Is it? Get the corpus for entering the corpus, go through and add them. Okay. And then here, when we update the coverage database, we update them by coverage. This should keep everything in sync, even remotely over the server. Everything should stay synced. So now all of them have the exact same things, and now we're only mutating on top of the same input over and over. So we're going to see a lot more of the NCAs because we're never going to let that input database really grow. So new inputs will get created as we find new coverage and learn different things, but ultimately we're going to end up using the same base input every time. That was That was an extremely complex way of using the same input each time, but more specifically, what it allows us to do is it will use anything in this folder as the basis for a new fuzz input. And that's a really cool operating mode. It means that remotely we can put files in this folder and it will automatically use that as the basis, and it allows us to kind of drill into those crashes. So yeah, I'm really excited about this. This is really cool. That was a really nice feature. I will probably end up using that a lot. Soding, thank you for following. Welcome to the club. Codino, thanks for following. If I missed that, I can't remember if I did. I've kind of lost track of time now. Arias Mies, I think I said that one because I remember struggling on that, but thanks for following as well. If I didn't shout out to that earlier, I don't mind if I repeat. Whatever, get an extra shout out. I've used super basic code, so I have no idea what's going on. So we are writing a fuzzer that is capable of fuzzing a whole system. And basically what this allows us to run like a virtual machine. We can have like Windows 7 running in an emulator. And what we're able to do is we're able to harness it in a way that we can corrupt a bunch of inputs and try to get applications to crash. So effectively what we've done is we've created these fuzzers that are fuzzing calc.exe. Calc.exe is just a standard calculator application. Comes with Windows, not anymore. It's been replaced with a new fancy one, but this is the old school calculator that we know and love. So what we're doing is we basically have a fuzzer that's clicking random buttons really fast. And we want to see if there are any situations where the calculator application crashes due to a specific sequence of inputs that we give it. And we have some very sophisticated tooling here that allows us to scale this out to many cores. So in this case, we've scaled it out to 64 cores in a server that I have in my server room here. And what we're trying to do specifically right now is we're trying to figure out a crash that we found. We're trying to figure out if it's exploitable. If the address that it's accessing that's causing a crash is controllable. And if we can get control of an access that the programmer is trying to do, we could potentially make it access something that it's not supposed to, which would give us control over the application. So that is effectively what we're doing. We kind of went down a couple paths because we're working on this tooling that allows everything to scale out over the network. But right now we're trying to drill down and we're trying to get this NCA crash that's accessing this address, this bad address. Effectively, what we want to do, we want to see this controlled. We want to see a combination of 41414141 in here. So it's like a weak spot checker in a way. Yeah, exactly. We're looking for weaknesses. We're looking for flaws that developers made when they wrote an application. So automating, verifying the crash is exploitable. Nope, we're just fuzzing. But in this case, we're fuzzing in a very unique way, such that we're fuzzing with something that modifies kind of these random grooms inside of it. So we're trying to see if we're able to change the state of the calculator's heap such that this address that we're dereffing here changes to an address that we can control. So what we're going to do is we're going to take this server offline. And then we're going to put this back. I want to do grooming mode here, but down here, I want to do if false and grooming. This will make sure that we always use this mutation mode. We're going to go into here, and we're going to write a new mutator. I'm just going to spin this up. But basically, we have an input that we know causes a crash. So in this case, we can reproduce that if I can find the right terminal. We've written a lot of code today, so I've kind of forgotten where we are. That terminal is that. This terminal is that. This one is that. Okay. So what we have is we have these fuzzers that we spin out to this server. So all of these guys check in, they're doing this fuzzing, they're reporting their crashes to this directory. Then what we do is we take these crashes, and we can take these crash files. I need to resize this to fix this. Inject ID, live repro. And what we're able to do is we actually hacked up this application a couple times to do some things for us. So I'm just going to close out these Vim tabs, make sure that we don't have a copy of that open. We don't. Set the GUI font, and effectively, we were playing around with some things in here. So we're going to remove that. We're going to set this back up to its standard operating mode. So we have this program here that is going to read in a crash file, one of these crashing inputs. Then it's going to basically parse the crashing input file. It's a vector of U32s. It's a bunch of ints. We're going to delete the registry keys for a calculator. We're going to launch a calculator instance, in this case Win32calc. We're going to attach to it, and then we're going to send it all of the commands that were told to us cause a crash, and then we'll return out. So what we can do is we can take this application and we can pass it a known crashing input for calculator. Here, we see we get a crash, and in this case, we're accessing some invalid address. If we do an analyze, or non-analyze, if we do a heap p a on this address that we're accessing that's faulting, we'll see that this is actively allocated and it's 238 bytes. This is out of bounds of that of this allocation. And since this is not a dynamically computed out of bounds access, RCX does indeed point to the base of this allocation, this 20 DC0. Due to that, the only thing that really makes sense here is a type confusion. There's a situation where calculator is accessing a field of a structure that it thinks is one type, but it's actually been replaced due to a race condition, due to just weird interactions with the GUI. It's been replaced with another type. So this is basically the bug that we've zoomed in on right now. We're trying to dive into this and see if there's any way that maybe this is controllable. We actually have a couple different crashes we're using. But yeah. Or due to Microsoft loving to use CCAS. Yep, there's so many things that can cause issues here. To what extent are you able to groom the heap with the clipboard? How much input will it take? Isn't that not clear yet? We did up to 4K of pretty much arbitrary data, with the exception of we can't do double nulls because it's a double null terminated string. So basically enough for anything we would need. There's no way that there's going to be an object greater than 4K that we're going to need to control. And even if that were the case, I'm sure we could find a way to control that or manipulate that. This is funny. I watched a crash occur like 6 hours ago. Did you ever verify it being type confusion? We haven't verified it, but we've kind of strengthened that as a concept. We've really had nothing that has violated that assumption, so there's really no reason to believe that it's not a type confusion issue. So, of course, it could be a very sophisticated use after free, where an entry is where a heap allocation is being freed and replaced, and then we're accessing it here. Really unlikely. Really unlikely. Okay. So we have this kind of fuzzing. It's always using the same base input. And I'm going to change this. We're going to put all of our good crashes. We're going to put all of our good crashes into that folder. So we're going to clear out these. We're going to delete these coverage files. We're going to go into some of our historical crashes that we've saved off from previous fuzz case runs. And I'm going to go into dev Actually, we're not in dev. We want to be in Twitch fuzz calc. Crash results, overnight crashes. We're going to get everything that starts with an OXOD. So we want all of these crash files. We're going to put these in the corpus. Then we're going to go into this one. We're going to do the same thing. Any of these OXODs, we're going to grab these. Okay, that's going to replace those. So now we have all of these different unique crashes. And then finally, I want to get a couple of these that are non-stack bugs. So I think, I'm trying to think where I have those crashes at. Read user 2585. This one is a real bug, so we're going to take this. That file's good. So I'm going through and I'm very quickly determining which crashes look like they could potentially be exploitable or groomable. And I'm making copy of those into our corpus such that we use those as other inputs. So here, CR2 is 3A. Looks good. This is a valid crash. Help pane, read user. This one is probably a valid crash as well. It's probably a duplicate. Looks like a duplicate, but we'll grab it. NTDLL, we have a crash in. This one is at 2.3. Where's the stack at? DA. This is a valid crash. So effectively what I'm doing right now is I'm looking at where these crashes are occurring, the faulting addresses, which is present in CR2. And I'm just copying these crashes. So like this one is a really bad crash. This one is faulting, trying to write to an invalid address. That might be one of the best bugs we have so far. That's writing to null. This one is writing to a 6.3. That's the stack. This one, 6.3 stack. We've got all the D's. Okay, so we've kind of grabbed all the inputs from that, and then we can look at these ones. This one we know is a good bug. I think we already have a copy of this. So I'll paste this in here. Here. This one's good. If we don't have it, we do. This one's good. This one. That one's really good. Oh, that's a null. It's a null, right? Never mind. I mean, it's still interesting because it's a write, so it should be like higher up in our priorities. That's a stack overflow or a stack overrun. That's also a stack overrun. I'm just trying to make sure that all of the good bugs that we have, this one looks really good, end up in this folder. This will cause us to try and reproduce these bugs. And only specifically these crashing bugs. We've got write to null, write user. I'm basically just looking at the CR field to see if they're stack or not. Okay, those are good. So this folder now has basically every single way that we've seen this crash in a way that looks potentially exploitable. And this will allow us to now spin up a fuzzer, spin up all 64 of these workers, and they're going to try and mutate and try and find different ways that these crash. Stack overflows are useless these days. Technically, they aren't. They technically aren't. There's a weird limitation of most of the stack checking stuff, and I'm not going to mention what it is. Still trying to get that one fixed. But yeah, stack overflows are still exploitable in certain conditions. Without a cookie leak, it's kind of busted. Okay, so these are almost online. They're just kind of syncing all their information. We got some page faults coming in. And now these are going to really densely be trying to find crashes. We can see these addresses. Actually, we want to be in calc.exe crashes. We can see these crashes 30, 30, 30. A bunch of these kind of with interesting values. So what we're going to do is we're going to run this for a while. And we want to get something. If we can get 4 ones, we'd be really happy. It's unlikely, but it's possible. So I'm going to pull up another 256 cores on this server. So we'll get that up and running. And this will basically, we're going to be mutating and trying to find all the different ways that this can crash. Hey, Liv. Good night. Thank you for following as well. Thank you so much for stopping by. I hope you had fun, even if it's something you don't necessarily understand. Okay. So we're going to want to change our mutation strategy. We actually never wrote a mutation strategy that was too good here. So we might start working on a better mutation strategy. Let's see. But yeah, now I'm just looking at the addresses that they're faulting on. Specifically, I can filter by .crash. And this is now going to tell us all of the unique crashes that we've seen. Oh yeah, exploiting Stack Overflows is a pain in the ass. I throw my Stack Overflows in the trash as they come in. I would only ever use a Stack Overflow if I were desperate. So basically what we're doing is we're taking these input streams, these command streams, and we're randomly putting heap allocations of random sizes into the input streams. And our goal is to try to find all of the different ways these can crash. Hopefully, eventually we would maybe put an allocation in the right spot, which would then cause this to pick up A's, and then we're happy, and then we would know, hey, we have a case that we can go with, that we have control. Basically, we're trying to automatically groom. We're fuzzing the grooming of a bug. We're trying to randomly generate heap states such that we are able to observe a groomed bug crash without necessarily having our interaction, or without our like human analysis of figuring out what the bug is, all the ramifications of it, and so on and so forth. Hey, pen testing stuff. Glad you're here. Hope you're having fun. I'm trying to chug some water. It's starting to get dry out here since it's starting to get a little cooler, and my lips are chapped as fuck. Okay. Looks like this server's finally starting to output some results. So now we have 320 workers online. There we go. We're starting to get variants. That's looking really good. I guess I haven't hit refresh, but now we can see that we're definitely changing the ways that this is crashing. And I'm just hoping that one of these pops up with some 4 ones. Is it faster this way? Generically, yes. Specifically, no. So if we wanted to try and exploit a single bug, like a specific bug that we have found, it would be much faster for us to go and figure out that specific bug. But in this case, we want to be able to do this on all of our bugs. We want to see if any of our bugs can crash in a meaningful way. And for that to be, and to really do that, we kind of need to do it on everything. So right now we're kind of able to automate it. Yep, automate the groundwork. Look at the promising ones. So we know of these crashes. We don't care about like all of the different ways that these can crash while we're actively fuzzing, but basically we've relaxed the file naming restriction so that we see a little bit more details of these crashes, and we're trying to look for ones that crash in really weird ways. So like this one's really interesting here. It's dereffing something that looks like a string in Unicode. And we're just learning how they crash. So like this one seems to always crash with these middle parts zeroed out, which would lead me to believe it's like a misaligned access. So there's a lot of things that I can kind of learn based on these file names. All the 5.1 accesses are always like basically a null deref. Consistently, these come in with this pattern. And when I see a pattern like this, this will maybe trigger me to start seeing some suffixes and things that would make sense that I could correlate with certain activities. You know, if I kept seeing one that constantly had strings, I could go in and figure out what those strings are, and I could maybe try to see. I have two where? What are you saying specifically? The page faults here. What about the OX10? The OX10 isn't really interesting to me. That's null deref. Oh, are you saying related to these? So here's another one that's a string. So we're seeing this 2AC01 constantly has things in it that look very similar to a Unicode string. And in fact, I think all of the ones that look like a Unicode string are 2AC01. So now we've learned that that variant is kind of the one that we might want to look into. So we could reproduce this crash pretty quick here. Let's pop up debugger, and then we'll go repro this one. Okay. So we're gonna spin up this, and we're gonna say I would like to repro this crash, and we'll get this up in the debugger and see what it looks like. So the fact that here's what's interesting about what the information we're seeing. When we see that a 2AC01 can crash with different contents, it means that it's not like a global lookup or a fixed restriction. It means that there's some changing data inside of calculator that is being used to compute that address. And what that means is that this might be controllable in some way. For example, if we saw a crash that only could crash in 3 different ways, we would just kind of assume that maybe it's fixed in those 3 ways. Like there are 3 options. Let's say it's let's theorize here that it's a type confusion between these 4 different modes that the calculator can be in. So if we saw a bug that could only crash in 4 different ways, it would be safe to say that it's likely a type confusion, and it's likely because of the different modes that the crash occurred in. So one is crashing because it's in this mode, another in this mode, another in this mode, another in this mode. But if we see that a crash crashes in like hundreds of different ways at the exact same location, there's no way, well, it's theoretically possible, but unlikely, it's probably a controllable thing. It means that it's relying on something that is very dynamic in the application, and things that are dynamic, we can hopefully do an action right before it does something and get a groom or initialize a value to something we want to control. So here we're going to repro this crash. Which one are we doing? We're doing the 2A203639. We're just waiting for this to repro. Here's the repro. We can take a look. Here's what we're dereffing. Obviously, it's pretty broken. If we look above, we're able to see that this came from racks plus 18. So if we look at racks plus 18, we can see that it's a 16 space asterisk. And here's a 101011. Like, that leads me to believe that this is leftover heap data from, this makes me believe that it's leftover heap data from the screen. This looks like an expression. A 16 times looks kind of like an expression. Here we have another 2AC01. Once again, all of these are numbers. This is an A followed by a 9, followed by a 7, followed by a 3. So this looks like it's picking stuff off the screen, which leads me to believe that this is an uninitialized memory use. Now, we don't have page heap enabled in this specific VM. If we had page heap enabled, we would be able to figure out what size this allocation is, and then we could try to target that allocation size. But we can see it's crashing. Okay, so here it's crashing at 2 different locations with the same DRF. That's really good to see. Here we have another crash. It definitely looks like this is dynamically computed data that we have control over. Or we don't directly have control over, but looks like something that maybe we could get control over. So it's hard to say if this is uninitialized data being used out of the heap. Maybe this is a field that's not filled in and it's left over from some screen contents. There's also a chance that it's a type confusion and the screen contents happen to line up at that location. What we would prefer is like a use after free or an uninitialized memory use. Yeah, it looks very type confusion-y. Yeah, I'm pretty sure it is. Although I think this is type confusion, but it's using an uninitialized field out of the structure, which might get us the control that we need. So it might be a type confusion that can be exploited due to an uninitialized alignment of one of the types that you can collide, if that makes sense. So we could start typing a bunch of A's on the screen and maybe see if we see it show up. So I could try and find the button for A. Now it's really time for lunch. What time is it over there? $12:13? Oh yeah, definitely lunchtime. Get a good lunch going. So yeah, it doesn't look like it's changing too much. If we had page heap, we would be able to like go and look into this crash. You know, I actually might have saved one. Let's take a look at crashes. Yeah, here we go. So I saved some ones back from when we were doing live fuzzing instead of snapshot fuzzing that had page heap enabled. And here's what the bug looks like. This is the 2A5A5. So 2A5A5 is using uninitialized data in a DREF. And if we take a look at heap, actually UB-RIP, DB racks plus 18, this is the uninitialized field. Heap PA racks plus 18. We know that this is in an allocation of 220 hex bytes. So what we're going to do is we're going to tear everything down, and we're going to switch. We're going to tear everything down, and we're going to switch to using that as our groom size. We're going to hard code that groom size, which will increase the frequency that we generate the correct size groom. Because right now we pick a random groom, which means that it often will not overlap with that size. So we're going to take a look at... Did I close my Vim window? I totally did. GVim, plugins, calc fuzz, source, lib, and here, set the GFN. So now what I'm going to do is instead of picking a random allocation size, we're just always going to use, we're going to do let elk size is equal to this random value. And now we're going to do elk size. So let elk size, we're just going to replace it with an OX220, I think was the number. So we know it's a 220 hex uninitialized read, OX220. So now we're filling it in an object that we know. Okay, yep, we're filling in a bunch of shit on the heap of that object. And we're replacing a random place in the input. For that in that. Oh, we don't want to do that many corruptions. We'll do just 4. So that and up to 4. We'll replace up to 4 with a grooming primitive that we know works. And semicolon. Actually, I need to be careful about this because that's going to make 220 bytes plus, let me actually take a look at our application. We do have to add a null terminator. I need to make sure that we're in the right heap bucket. And if I don't put the right terminator in there, we probably won't have it. So let's, where are we at? Elk size, dev. We are in Twitch fuzz. This is the inject ID sequence. We're going to take a look at what we did. I think we added 8 to it. We get the size from the command. We get an allocation of size plus 8 bytes. So what we want to do is we always want to do 220 minus 8. That's going to allocate 220 minus 8, or 220 bytes hex total. It's going to fill in the first 220 hex minus 8, so the 218 hex bytes. It's going to fill those in with A's, and then the remaining 8, it's going to leave nulled out. And we just need to have a null terminator on there, and we added 8 because UTF-16 can get wonky, so we were just adding some extra padding there. So this will now really drill into that specific... this is going to drill into that... I'm going to get rid of these extra terminals, whichever ones we're doing. Okay. So we're going to spin up the server now. And this is now going to hammer putting in grooming primitives of the size that we know can get hijacked. You still use Ghidra? Yeah, I just use whatever tool I have sitting around. I'll use Ida, I'll use Ghidra, I'll use Binja. I have all of them. I'll continue to pay for all of them. They're all useful in different scenarios. Okay. So now we have this up and running. Let's see what we get. We have the folder still open, right? Yeah, we do. Okay. Oh, never mind, we don't. Dev TKO Franzia crashes. So now, star.crash. Now we wait. Now we see if somehow we can fill in that heap. Somehow, in any configuration of any of these crashes, we might need to add some reordering of these commands if we really want to make this good. But this is specifically trying to fill in a known allocation size with 4 ones such that we catch that uninitialized use. So, got these up and running. I'm going to bring up my other server to bring up another 200 cores. All right. And now we wait. Yeah, it's hard to say with these if we're going to get an arbitrary placement. Now, since we have this crash, we do know that with page heap, that this is an uninitialized memory access, and thus we're likely, since it's uninitialized memory, a heap allocation occurred in this change mode. There has to be a way. There has to be a way to do this. There has to be a way to land this bug. It's just, there's no way this bug is not landable. I hate to say it. or not landable, but controllable pointer deref. Although we have seen writes to pointers that might be controllable as well, so it's possible. Definitely possible. What is this? I lost some threads. This is complaining that some threads may be panicked. What happened here? Failed to download the corpus. Okay. Oh, this is getting really slow. When these spin up, I guess I probably lost a connection on one of these workers. It kind of sucks. Okay. These servers aren't, the clients aren't going to be able to report crashes while we're bringing the server up because it's just hogging all of the server time. So once these finally get up and running, which is hopefully soon, we'll start seeing some crashes. Looks like it has calmed down. Still downloading a lot of pages. Once these start printing, we'll know that they're actually up and running. Oops. We know that these are up and running, but this server's just taking longer because this server has a lot more cores, and my synchronization stuff could be improved quite a bit. So we might actually want to do that. No new crashes so far. You know what? With the clipboard thing that we're doing, we might never be freeing that clipboard entry. We might be causing allocations to occur, but if we're never freeing them, then we would never be able to fill in one of those slots. What we want to do is we want to allocate, we want to fill it with A's, we want to free it, and then we want another guy to pick it up and use that uninitialized data. So trying to think here if we're freeing that. We could add some instrumentation into the target and get us some visibility into how frequently that is happening. We could also drill into one of these crashes specifically and try and fuzz one of them. Okay, all the cores look like they're coming online now. All right. I'm surprised we've gotten nothing new. That means we're likely not affecting the state as much as we'd like to. Makes me kind of sad. Definitely finding crashes though. What do we got? Anything? No, nothing. So there are a lot of things we can do to try to improve this. We could try to figure out what this transition is here, and we could try and drill into this specific transition. So we know that the toggling history, if we can reliably cause this allocation to occur after we cause... I think what we want to do is we want to figure out a way to get an allocation of this type. So if we go and put a breakpoint on this location, we want to get an allocation such that the 18th offset contains 4 ones. And I think we're getting to a point that we're going to start doing some of this manually, because this is the amount of effort we'd have to put into this would be pretty excessive for how simple I think this is to groom. In fact, this might be a 30-minute groom here. So let's see, unless there's a lot of heap activity, but 220 is luckily a large heap bin, relatively unique, so the odds are we can kind of control that. But I'm gonna take a quick break here. I'm gonna grab a snack, and I will be right back, and we'll start looking into maybe grooming this specific bug in this case. So see you guys in a bit. Did we do it? Did we get 4 ones? Probably not. I don't think our paste is actually working frequently enough. So what we're going to do is we're going to try and drill specifically into this. And we're going to try to always get it in a state where there are 4 ones in a 220 bin when this occurs. And we're going to see if we can do that manually. Given this isn't truly an uninitialized memory use, we likely can find a way. The question will be on custom commands. The question will be basically, are there any allocations or frees inside of the user size? Is there anything in this bin that maybe would knock our allocation out of the bin by the time that this object gets created in this path? And this call stack looks relatively shallow, so we can probably get a message in here because we're basically sending messages. We probably can get a message in to the window procedure that would cause us to get this allocation to occur, and all we need to do is make sure that our paste is the most recent thing in the 220 bin prior to that. So let's see what we can get. You just got a bunch in. Some of these are starting to have, this has 2 4-1s. It's just 2 A's. This one's actually interesting because it has a 7-6 and a 6-4. I want to see what this one is quick. Kind of makes me wonder what that could be. Because we've only seen that with like, we've only really seen this crash with spaces and like hex digits. This one is kind of breaking that trend, so I want to see what exactly ended up in that command buffer. So we'll get this going, and let's repro this bug. Oh, you want full screen? Here you go. All right. Okay, here's our crash. Okay, reload. RU rip. UB rip. UB rex plus 18. 8 space ND. It's hard to say what necessarily was in here. I'm not quite sure. So I think we're going to have to dive in and be a little bit smarter about what we're doing. So we'll hop over and take a look. So we basically need to figure out what causes this to occur in calculator. Actually, we care more specifically about this, but we can take a look at this function. And more specifically, we want to disassemble behind this 3C. We want to get the address before the call. It's probably this -5. That's kind of the standard. Could not find previous instruction. No. Okay, so that's kind of broken, but let's see if we can just find the new. Got our VF table. Set current mode. Here we go. I thought I saw new. Did I? Yeah, here we go. So this is where we want to go. So we're going to open up another Winbag instance, and we're going to pop open calculator. Windows System 32 calc, Win32 calc.exe. We're going to put a breakpoint on this. We want to do, this is fine. So yeah, this is about to allocate a fixed 220 hex size allocation. BP on this, go. Okay, and what does this say in the stack? Layout stats mode. Toggle history. Well, toggle history happens, that's where the crash occurs. If we look at the heap allocation, is that RCX? Was that RCX? No, RDX. Actually, this racks. Heap PA racks. So we see that this is crashing in layout stats mode. So I'm pretty sure if I just select stats modes, I think we just win. No, not quite. Do I need to add history? No, there's no history in stats mode. Toggle history function. Basically, I want to find out how we hit this breakpoint. That opens up help. You know what? It's probably stats 5, add 5. Is it editing one of these things, maybe? Data set clear. Huh. Let me see if we hit layout stats mode ever. Just the root function. Oh, that oh, that didn't resolve because it's Win32 calc. My bad. Yeah, it's probably always inputting to the number window. No, we're actually not even inputting to the number window. We're sending it to the main window, and we're sending like random button clicks rather than actually typing. Obviously, that would make our fuzzer much better if we included that. We just haven't done that yet. We've been kind of sidetracked on looking into some of these crashes, and then we've been sidetracked from that by just basically writing good code. So we're gonna put a breakpoint on Win32 calc this. Oh, not Win32. We're gonna look at Win32 calc. And I can guarantee you that when we leave stats mode and re-enter it, this will get hit. No. Okay. Okay. Let's put a breakpoint on the main part of this function, layout stats mode. This might not get invoked twice. Oh, there we go. So we hit layout stats mode. I could be sending stuff to the text boxes in the stats bar of the window. I don't actually think we are. I think those are not accessible because we can't type via buttons. So here we hit layout stats mode. I'm guessing we weren't hitting the other breakpoint because we probably, this might cache this. So the stats mode, it might only be used the first time you switch into stats mode. That would be my guess. Is what we're gonna have to do is we're gonna have to create that allocation, and then we want to switch into stats mode for the first time. So if we step through here, we're gonna not branch here. Oh, we are gonna do our allocation. So it looks like every time we go into stats mode, we're gonna get this allocation to occur. And this is relatively shallow in a stack, so I'm pretty sure we should be able to get an allocation to fill in there. If we take a look after that instruction executes, or after that function executes, we see everything is filled with C0s. So what we want to do is we want to get this in a situation where it's filled with A's. So let's refresh this. No progress on here. So what we want to do is we want to programmatically cause an allocation in the 220 bin of controlled data, followed by a switch to stats mode. So I think if we special case the fuzzer to do that transition, we'll likely be able to see the different ways that it can crash. So, okay. That looks really good. I'm going to start opening some notes here. I like to take notes of all these breakpoints that I'm setting because I'm eventually going to lose this WinDebug session, and I'll want that command to grab it and throw it back in again. Okay, so now what we want to do is I want to grab a file, and I want to fill it with not. So I need to compute the size of it. So it's going to be 220 hex bytes is our character allocation allowance. We're going to divide this by 2. This is the number, or that is the byte allowance. This is now the character allowance. Subtract 1. We want 271 A's. And this should give us a perfect allocation of one more. So this, when converted to a UTF-16 string and added, has a null terminator added, should be 220 hex bytes exactly. And what we'll do is we're going to confirm that by grabbing our injection application. I think we actually have a window open already. I mean, we have a window open for pretty much everything we've done today at this point. That one, live repro. And we probably have a live repro window open. Yep. So this is the inject sequence one. This is not the live repro, but this is the information that I want. So we're going to go into source main, set. And what we're going to do is when we launch all of this stuff, I want to cause 32. I want to cause a clipboard entry to be added. In this case, we want it to be of OX220 hex bytes total. And then for this, we'll do OX220 over 2. Actually, OX220 minus 2. So fill it with A's with 1 null terminator. That should be good. Then we're not going to be able to paste at that window ID. We're just going to use, we're going to temporarily use this application to print loaded into clipboard. So if we run this, okay, we get to that point where we load stuff into the clipboard. Well, of course, that ends up crashing. So we'll restart this calc session. We should have all of those A's. We should have all of those A's in my clipboard right now. If I grab cheat engine, and we're going to take a look at calc's memory. We're just going to search for a bunch of A's. And we don't see any. That's good. I'm going to now hit paste. Let's see. Let's get this to exit after we load into the clipboard. Okay. Looks good. This will spawn a new calc instance, but it's not a big deal. Okay, we should have that in the clipboard now. Paste. Failed first scan. We have all these A's now. This is the address that the A's got allocated to. So now I can take a look at this. We see all our A's. Now I can do a heap PA on this address. And we saw we allocated 220 hex bytes in this trace. So we were successfully able to create an allocation in the correct bin. Now what we need to do is we need to free that. And I think to do that, if we just do another paste of a different size. So if I paste, in fact, I can just take like this 4. Yep, actually by just copying something new to the clipboard, I was able to cause this memory to get freed. And if we take a look at this address, we'll see it's now actively freed. If Winbug doesn't freeze. So we'll see that this was actively freed. And it looks like this was freed due to, it cleaned out the previous state just by doing a, just by sending a copy message will do the trick, actually. So now what we want to do is we want to start kind of automating some of these things. So we want to figure out what menu item causes us to switch into stats mode. So like we want to do calculator will start up in the initial state, which is this. We're going to want to enable unit conversion, which will give access to this text box. We're going to want to paste into that text box. We then want to copy again from that text box to cause the previous allocation to get freed, and then we want to switch into statistics mode, which will cause this statistics structure to hopefully be allocated with the A's as the most recently freed thing on the heap. So that is what we're going to automate right now. We're going to do this very manually, and I think that's just the only way we're going to get through to it. So if we look at enumerate menus, so let's take a look at all the menu options that we have in calc. We'll do primary window dot enumerate menus. And I think that should work. We're gonna close this debugger session. In this case, it's not a double free, I don't think. I think it is a type confusion, but we're then gonna try and groom into an uninitialized field in the type confusion, but we're also making a guess. So, so we really have no idea what this bug is yet. It wouldn't take too long to figure it out, to be honest. Okay, so this is enumerating out all the menus. These are all the different menus that we have. I'm going to assume that this is 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to guess 305. If we send a 305, I'm going to guess that that will put it into unit conversion mode. So we'll do a primary window dot command 305. We're going to see if that does the trick. We might need to put a sleep in there, so let's do standard thread sleep, standard duration from millis, standard time duration time, and we'll just sleep for a second. Okay, so that did not work. Maybe I need to advance this a couple. Let's just kind of go down this list. Nope. No, interesting. 8? Huh. I don't think it's 158. Maybe a 300. 300, I think, is the calc mode. Could try 301. See if that puts it into scientific mode. No. That's kind of strange. Oh, that opened help. So that one was the help. So 965. Nope. 1056. No idea what that did. I'm guessing these are probably the calculator modes because there are 4 of them. This will probably go into scientific mode. What the hell? Kind of confused here. Well, we'll just do this. Sleep for ID in this. Send ID print sending ID this. What? Why not get menu string? I just don't want to add it right now. But yeah. I was just assuming this would be a safer... Oh, this. That's why. Okay. I'm just trying to save some time. Which at this point we're probably losing by not doing get menu string. But you don't win all of them. That opened help. It's really strange. Maybe sending these commands is not... like, I know that we've seen this working. I think we have a calc open. Yeah, we do. Well, that just crashes it. Um... 9e crashes it, so we'll say if ID is not equal to 9e. Now we know we're sending it to the right calculator. I think we're sending it to the wrong calculator. Son of a bitch. Alright, we're gonna do this. X1, 2, C. I feel like we're getting close. Fuck. And ID is not equal to OX 9E 9 or AO. There we go. Nice. Okay, cool. So I think it was 136. I might have missed it. Not a big deal. I'd rather do this than type some code right now. Just bang my head against the wall, figure this out. And we'll put a sleep in there. Maybe it wasn't 136. Probably wasn't. Okay, doesn't matter. We'll just go down the list. 3C5. Well, that put it into stats mode, right? Oh no, that turned on history. So that was history, right? Yep. So history is this. That means we can just go down the list from here. 132 calc, history, digit grouping. It'll be probably this 3D3 will probably be the unit conversion. There we, ooh, that was date. Let's go one back. 3CF. Date conversion would work as well. There we go. So this is unit conversion. Okay. And now we want to be able to put it into statistics mode. Okay, that one was about, so it's not that. 3C5. 3CD, 3CF. Oh, 3C5 we know. Shit. Was that one of these like kind of earlier up? Okay, and I think we just go down the list here. 1. Really? Okay. That's programmer. Is this stats? Is this the hidden stats menu? There we go. So this is stats. Okay, and now we can open calc and spy, and we can take a look at when we have unit conversion open in statistics mode, actually before statistics mode in standard mode, we want to take a look at this text box. And this is E2, so we know that the paste text box is OXE2, first from value for unit conversion. Maybe crashes occur because we send a command of a menu delimiter. I mean, it's still a crash because the application is responsible for handling it. So if that is the case, that's possible. I'd hazard to say that's even likely. But okay, so we're gonna send a, but it doesn't really matter to me. You know, I'll take any bug I can get. So we're gonna send a 3CF to turn on unit conversion. We're gonna then paste. We're gonna enumerate all the windows here. We're gonna find the E2 window, OXE2. So we're going to turn on unit conversion. We're then going to find the E2 window. We might have to put a sleep in here. And then we're going to paste into the E2 window once we found the handle for it. And I'm just gonna put 4.1 in my clipboard. So what you should see is we'll launch a calculator, we'll open unit conversion, and I'll paste a 4.1 in the from box, and we didn't. Let me see. Oh, that's not my clipboard. Oh, we're fucking up our clipboard here. So if I comment this stuff out, if I load up, in this case I'll do 133. We should see a 133 get pasted into there. Perfect. Works exactly as we want, which means this was working. So this is pasting A's. So what we should be able to do is run this. Then if we do, if we take a look in Cheat Engine on that calculator instance, we should find a bunch of A's in there, and we do. So that's really good. Okay. So now that we have the A's in there, we want to make sure the A's get freed. So I want to confirm. So I guess if I just copy in any window, those will get freed. Control C. Not quite. I think a copy needs to be sent to specifically this window. So I will, right after we do a paste command, we'll do window.copy. We have to implement the bindings for the copy command. Paste. Sends a clipboard copy command to the window. Copy, I think it's 1. Clip copy is what we're going to call this because copy is a reserved keyword. WM copy. It's a 301. Yep. So then we're going to go to the paste implementation. We're going to make a copy of this. And then we're going to make a copy implementation. Attempts to into the clipboard from the window. Send the copy command. Good. Okay, so now we're sending a paste command. Then we're sending a copy command. So what I'm going to do is we're going to close this window. And I'm going to put an excessively long sleep in here of 10 seconds. And what we're going to do is we're going to run this. Oops. SP source win bindings. Clip. Okay. Well, it's not a keyword, but it gets highlighted in a weird way, which is what I'm trying to avoid. Okay, now we want to attach this really fast. No, we're scanning for A's, and then we want to see that these disappear shortly. They did not get freed. So I think what we're going to do is populate the clipboard with something else. and then we're gonna do another clipboard operation. So we're gonna do pub, we're gonna do fn, copy clipboard contents. This will take a buff of u8s, or place into clipboard, load into clipboard. Here we're gonna do buff.len, and then this will be, we'll no longer write these bytes in here. We'll now do a center mem copy non-overlapping. We're gonna copy from the buffer into the pointer for buff.len bytes. Standard pointer, copy non-overlapping. We're just gonna do it as pointer. Okay. Now we can do paste into clipboard. Here we're just gonna do paste into clipboard. We're gonna put in a vec of let contents is equal to a vec new, actually a vec of OX41 times 220 minus 2. Then we're gonna do contents dot push 0. We'll put the null terminator on it, and then we'll paste these contents, placing those into the clipboard, do a paste, and then we're gonna do this, but with new contents, we're just gonna do a byte of 00. So we'll null out the clipboard, and then we'll paste that into the window. So 41, 220 minus 2, push 2 things on there. Now it's 220 elements long. Okay. And we're gonna do the same thing we did before. Yep, not mutable. Okay. That should have done its stuff. We can now search for A's. Here are the A's, and then in like 5 seconds. Nice. So those got freed. Let me see if I need these sleeps. Well, it's actually kind of hard to tell on this one. Let's see if these sleeps are necessary. I don't think they are. What happened there? Yeah, so the window, I think a sleep is necessary after this for the window to update and render. So, this case, this one should have worked. That looks good. Should get freed. Those didn't get freed. That might not have been long enough. All right, we'll do a second. This, we can instantly switch the mode, but we have to wait for the rendering for the enumerate sub windows to find the window identifier for that. But this should work now. Really? How did those not get freed? Paste in a clipboard, paste. Isn't the only thing we changed is this? Okay, calculator, nope. New scan. Got some A's. Maybe that sleep is necessary. Maybe. Yeah, since I'm out of process, I might need to sleep. So yeah, for sure. Let's see what we can get away with. See if we can go to 250. Actually, I can just go down here and I can say, break scan for E2. Here we'll do a loop. Loop here. Could probably get away with 60. It's actually kind of difficult because the calculator process has its own like animation shit that it does. So here what we're gonna do is we'll never break out of this until we, so this is gonna be sent in groom, and then this will be freed groom. should do the trick. So we saw the mode change, so I don't know why we would need a sleep prior. That would make no sense to me. So there. Scent and groom. I'm gonna see how fast that showed up. That was pretty quick. Yep, scent and groom. It's almost right away. If we take a look, the groom is indeed here. Oh, I think it ended up in multiple locations. So this is the one that actually got freed. Looks like everything is good there. We should be able to probably do this now without sleeps. So we can get rid of this. And now that's going to cause the groom to occur. And now what we want to do finally is we want to primary window dot command OX133 to switch it into stats mode. And then we're going to want to do this on Windows 7. So basically, that ended up in stats mode. So this will do everything and end up in stats mode. And hopefully that stats allocation will pick up 4 ones as the fill value in that buffer. We can also take a look at crashes and see if we have anything. 296 workers. Got some good fuzz cases going. Let's see what we got here. Nope, doesn't look like anything has landed. But the odds that this sequence gets generated during fuzzing is very low, especially with the delay required after an animation change. So, so this should be about as fast as we can possibly do it. And then we send the 133, change it into stats mode. And yeah, I think we're just gonna... I think here we want to do command winbag.args, and let's see what winbag takes. Can I just take an exe like that? Yeah, it can. And we can skip the initial break, which is key Feinster I break. There's a way to disable the initial break-in. Where is it? I think Winbag and Katie have the same command line args. It's possible it doesn't, so we can go look at Winbag, pull up the help, and we can put in break or command, like the command line options, Winbag, break. Oh, dash G, lower G. Okay. I guess maybe that isn't an option for this. Okay, it is not. Win32 calc. We'll put a dash G in here. Win32 calc. So this will now launch Winbag, or this will now launch it automatically under the debugger for us, which is nice. But I think we actually want to get advanced, and we're gonna do a C on Win32 calc, and we're gonna do a G. We're gonna do a BP. We're gonna do a breakpoint on this semi-G. Now we're cooking. We'll just do this. Nice. So now we break when this allocation occurs. So we can go past it, db racks, and we'd be able to see the contents. What did I do? I did a go up on accident. That was my bad. Actually, wow. I think we hit that even before like rendering happens. So step over db racks COs looks good. Heap PA racks. If we look at K, we'll see that this is the window procedure, blah, blah, blah. Layout stats mode. Cool. So this is exactly, everything looks good here. And now we just need to change this from Win32 calc to calc.exe. And I don't know if this is going to be at the same offset, but hopefully it is. Calc.exe. Now we can build this. And we're going to inject this into our Windows 7 VM. We'll boot that up. Oops. So hopefully this address exists in the other calc. So we're using a different version of calc. So there's a chance that it behaves slightly differently. There's a chance that the ID's changed. But let's see what we got. We need to just do a... What do we got? Inject ID sequence of an OXOD. Okay. Couldn't resolve calc. Oh, I don't have symbols at all in this VM. Shit. Let me pop the symbols in here quick. Any new crashes? Nope. So we're gonna go into symbols calc.pdb. I'm gonna grab this PDB, go into here, VHDs, pop this open, smash this into here, eject and boot. Okay. I don't want that. Why is there a fault-tolerant heap shim being added? What the hell is that? Does that mean it, like... Does that really try to make it so crashes don't crash? Oh my god, that's so gross. Let's take a look at this. Let's see where their operator new is. Yep, it's now at offset 37 in this version, so that has slightly changed. Build that. We're gonna copy Explorer, target, debug. Whoop. Inject this, VHDs. Yeah, I know we could automate this whole process. Blah, 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 blah. Okay, and eject. Okay. So this will now hopefully hit that breakpoint. Hopefully all the button interactions are the same. It's hard to say if they are or not. Yep. Inject OX. Huh. We're not hitting that. It's resolving. Let's check out layout stats mode. Let's go in there. So this gets hit. That is hitting it. Isn't this the right location? BL? Wait, did I typo 33? Son of a bitch. Wait, what? But the other one. The other one. What do you mean the other one? BL. How is that inputting it wrong? This is setting a breakpoint at the wrong location. I don't get how that's possible. Alright, we'll just do it manually. Different versions of PDBs for different calcs. No, that isn't the case in this one. So we're just gonna start WinBag, or we're gonna start calc on our WinBag. We don't care about the rest. Cargo run, get a new build, good, updated. VHDs, this, and then we're just gonna manually find the breakpoint because for some reason that command input is not working. Or I missed something really stupid, but I mean, we were sending it a 37 and it was doing 33, so it might be parsing that command wrong. PDB is the same. None of that should change between runs. So now we can do inject into OXOD. Oh, let's take a look at... so now we can do it at 37, I think is the good one. BP win32 calc, GC container, layout, stats, mode, plus OX37. It's just calc. It's just calc. It's just calc. Okay, and then this should be the new... No, it's not. See that? See that? We're setting a breakpoint on that, and it's setting it on the wrong thing. This minus calc. Or actually db this. So this is the offset. That's so weird. I don't understand why it's doing that, but we can do BP on calc plus this. We're just gonna make a note of this. And we'll move that to here. Okay, so this will put a breakpoint based on the module offset. Okay, we hit it. Step over, db racks. L20, L80. Okay, so we don't see our A's in there. So it's kind of hard to say, oh, do we have page heap on? I don't think so. I don't see C zeros in here. G flags I calc.exe. G flags I calc.exe. Okay. So let's make sure that alloc free is actually happening. We got to find the offset of those. So where did we see the allocation? So put a sleep in here, I guess. It's possible that these identifiers have changed and we're not actually... Well, we are setting We end up in unit conversion. We end up in stats mode. Everything looks good. I guess we just want to make sure that these clipboard contents come in. So I just need a stack trace of where those clipboard contents get allocated. So we're going to do a return OK here. Set this to 132 calc for the local version. And we'll just use, I think Cheat Engine's going to be easiest here to find that. Click that a couple times. And this is the allocation that we care about. So I can do heap PA this. This gets called in. We'll do get clipboard data. Yeah. Okay, I'm just gonna make note of that. And where does it get freed? So I'm gonna copy some, I'm just gonna like paste some shit into here, paste. Okay, now I should be able to look at that address again. We'll get to see where it got freed. In this case, delete client clipboard handle. That one looks good. Okay. So we just want to see what is happening here. We'll put a breakpoint on user 32 get clipboard data. Okay. We hit this in here. Looks good. Return up. Racks contains this clipboard data. We do a heap on racks. Oh, we don't have symbols. Well, if we look for DB racks L 220. So there's our 220. That looks correct. If we go to 230, we should see, yeah, this looks like the start of another allocation. So what we can do is we can put a breakpoint on where we currently are. So we'll put a breakpoint at this. Now I don't trust. Now I don't trust the. Oh, I can't use the clipboard. 7FE FCOAA. Actually, I can just do rip minus com control 32. Com CTL 32. This is the offset, so we're gonna put a breakpoint here. I'm gonna make a little windbag script. This is gonna be put a breakpoint at com CTL 32 plus OX CA7E2, and then when we hit that, we're gonna want to print a DB of racks followed by a go command. Then I want to do a BP on calc plus 13E7B. Technically, I want the instruction after this. Let's figure out what that is. A U of this. U calc plus 13E7B. Maybe also print the stack. Yeah, I could do that. Sometimes spaces actually hurt these commands in certain contexts. So now we want this at E80. And we'll do a DB of, once again, racks. KG. Yep. Access is denied, son of a bitch. We're going to save this in mesos. Foop.txt. Okay, so now I should be able to do this, and honestly I can just copy paste these. I don't need to actually do a script file. those look good. And now we're going to see the two allocations. So we see this allocation. Okay, we see A's happen here at 27C2E0. Then we come here and we do... This is another clipboard. This is when we paste again, I'm guessing. Right? Print this, print the stack. Okay, now we're printing this, and somehow we're here again. Yep, so this is another... This is probably when we send the 2 zeros to reset the clipboard state. And then we see this is the address that we got back. And what's interesting about this is, oh shit, the clipboard's in a global heap. It's in a different heap. Clipboard's just in a fundamentally different heap. If we take a look at this object, we don't have heap entry. Yeah. So we're gonna need to find things that get allocated out of the malloc bin. Fuck. BL, if I do a disassemble backwards on this. I don't know why this is struggling so hard. It's not a hard problem. Okay, we're gonna go into new, BC star, BP on this. We're gonna switch back away and into stats mode. Okay, and I just want to see what this call stack looks like. BP RTL allocate heap, and we'll put one on RTL P allocate heap as well. Okay. So basically, we want things that are using RTL allocate heap. We can take a look at the heap that we're using. RCX is the heap. RDX is... what are the arguments to this shit? I think it's the heap, flags, size. Yep, so we got heap, flags, size. So it's actually allocating 250, but I think... That's kind of strange. Because we're in this function. I guess there must be metadata being added. Because it's 220 to a new. Not that it really matters, but basically we're only going to be able to use allocations from this heap. So we need to put a breakpoint on RTL allocate heap. We want to conditionally print if RCX is equal to... if RCX is equal to this, then we can do a K. Otherwise, we're going to do nothing. In this case, we'll do a G. And we'll do this. BC0, BC2, BL. So we have one breakpoint now. This should now print all heap allocations, so all of the call sites for heap allocations out of that heap. Isn't that including the metadata, the prev next pointers, and heap flags? I'm not sure. Typically they don't when you do like a direct malloc, but it's possible that some weird stuff is happening. So 1, and then we want to print by size as well. Let's we want to grab. We cannot lose this string. So this value is going to change each time I think we run the application. Yeah, it could be alignment. It's actually, that's probably actually the size of the bucket. It probably rounds up to that bucket size. So 220 probably doesn't have its own bucket. The nearest bucket is probably the 250. Although I feel like RTLP allocate, or RTL allocate heap is who does the bucketing. So we're gonna print, we're gonna get rid of the stack, and we're gonna say dot printf. This is just the default heap. So we can do a printf of %d, comma, R8. So alloc size of x. We're gonna try this. Malform string. Yeah, we need to, I think, double escape this. Yeah, we don't have a heap of that, so we're gonna get rid of this check. We're just gonna print all allocs out of RTL allocate heap. Most will be out of the default heap anyways. We can actually print the heap, and here we'll do an ox%.16x. We'll do the same here. Actually, this will do a .4x, and we'll print the RCX for that. And we want a new line. We might need to double escape the new line, I'm not sure. Yep. So whack whack. There we go. Okay, so now we can see all of the heap allocations. Okay, it is using multiple different heaps, which is interesting. Okay. Man, that printf is super slow. That printf is unbelievably slow. Come on. So, I'm just gonna add a filter for this. Yeah, it needs to be out of the same heap. Okay. So we need to allocate something out of the same heap. Let's check in on our crash status. I probably should get heading to bed here soon. Oh, what do we got? We got Francia crashes. Yeah. Interesting. Okay. So effectively, we need to actually find a groom in the correct heap bin for that. Seema suggested reading Ponce, like the... What is that? Is that like flow graphing stuff? Taint analysis. Yeah, I don't really need taint analysis in this case. Just doesn't really help me. I need to specifically figure out what heap allocations I can cause in that specific heap. So I think we're gonna need to write some custom tools to do that effectively. or we'll end up writing some stuff in mesas and programmatically do some of that stuff. Has symbolic. I don't really need symbolic. Doesn't really help me here. Yeah. I think I'm going to kind of wrap up the stream here. We'll have to kind of look into maybe getting, we're going to have to make something that filters, and we'll look specifically for allocations and the call sites of those allocations in the heap that that allocation occurs in, because we're going to need to be in the exact same heap. Symbolic execution would be able to serve me the allocations on a plate? No fucking chance. No chance. The second you hit an indirect jump, just can't do anything. Just falls apart. It would figure it out if it's like 10 blocks away, but it just is not going to work on a full application like calc, especially with window interactions, because it won't be able to tell me how to control those window events. It would take more time to set it up to use symbolic here than it would be to just do it with dynamic. So, thanks everyone for tuning in. I'm going to end it there. So, thanks everyone. Had a blast. See you guys around. Thanks everyone who followed. Had a lot of fun. I'll take a look at Ponce.